Welcome, everyone, to the worldwide conference on delivering the human future. The purpose of the conference is to raise global awareness that we are not facing just one or two catastrophic risks, but many, and that they are all interlinked. My name is Olfa Miliani. I'm going to be your facilitator for this conference for the next 2 days. So I thought it might be useful to give you a couple of words about who I am. I am a lecturer on the future at the Halt Business School in London. I am also a principal at SWAF, which is a consulting firm that advises organizations on foresight and helps them prepare for the future. And finally, I'm also a sci-fi writer. I write novels that explore different scenarios and the impacts that they could have on humanity. So you can imagine that given what I do for a living, I was thrilled when I was asked to moderate this conference, which touches on all the crucial topics that humanity faces for the future. It's a great privilege for me to support this admirable initiative, especially given the fantastic range of speakers. Today, 8 eminent specialists in their field will introduce us to the risks facing humanity, ranging from pandemics, water scarcity, climate change, and biodiversity loss, to security and the threat that is posed by AI. We live in exceptional times, and it falls to us, every single one of us, to live up to the critical tasks ahead. Whether you are watching this now or in a few months, wherever you are in the world, whatever your age or gender or creed, it falls to you to avert these catastrophic futures. We were born into this world that needs us at this precise moment in history where our actions will determine the future of humanity and the planet. And so, as a writer, of course, I think of the great films and the great stories that we are told all our lives. And it's like in the movies and the novels, where the smallest person can make a difference. And we must accept this mission and step up to it. This is our chance to be part of something greater than ourselves. This is our chance to change the course of history. This is our chance to leave behind a world better than the one we came into. We must step up because the alternative is beyond our worst nightmares. Because the alternative is the end of everything that's good and worth living for. So like the hero who faces his darkest night of the soul, we must face to the challenge ahead and remember that we are part of a great story, that we are the heroes that will persevere in the face of adversity, and that we can triumph, that we must triumph, because no one else will save us. It's up to us. So with that in mind, it is my great pleasure to introduce you to our first speaker today, John Hewson. John is a professor of public policy at the Australian National University. He is the chairman and co-founder of the Council for the Human Future, and he is also one of the hosts of this conference. He is a former political leader in Australia and chairs the Australian Sustainable Development Council. An economist by training, John has worked for the IMF, the UN, and the Asian Development Bank. So it is a great honor to have him today to open this conference, and he's going to talk to us about the challenges that we face.
Well, thank you, Alpha. Fellow citizens of the Earth, I bid you a warm welcome to what we hope will become one of the milestone events of the decade, a worldwide conference on delivering the human future. Your hosts of this conference are the Millennium Alliance for Humanity and the Biosphere, or MAHB, based at Stanford University in California, the Common Home of Humanity, based in Gala in Portugal, and my own organisation, the Council for the Human Future, based in Australia. We share a common concern about the human future and the risks that we all face as members of a global civilization. Our purpose in holding this conference is to describe these risks in a way that anyone can grasp them and to discuss how we can best solve them. It is no exaggeration to say that humanity faces an existential emergency, a combined threat to our very existence. This is by far the greatest danger we have faced together since we first stood upright and walked from the grasslands of Africa into a world in which humans now dominate, utterly dominate. We are victims of our own success as a species. That very success now endangers us. We hear much about climate and extinction, but at the Council for the Human Future, you understand that there are 10 interlocked threats to our future, which must all be solved together. These threats have been identified, measured and remeasured by scientists around the planet for over half a century or longer. There is no question that they are real, there is no question that they are happening now, and there is no question that they are extremely grave. There have been countless conferences and meetings to discuss individual threats, such as climate change, nuclear weapons or extinction, and they have reached some very important conclusions about what must be done. However, the central message of this conference is that we cannot solve these threats one at a time because they are all interconnected. They are all driven by the same fundamental forces, human overpopulation and overconsumption of the Earth's resources. We must solve them together in ways that makes none of them worse off. To try to prioritise one threat is to invite disaster from another. I must admit in recent days to significant frustration and concern that global political leaders and policymakers seem to be so short-term in their focus, often ignoring the science, other significant evidence, and of course specific warnings of pending challenges and crises. However, at the same time, I've been encouraged by collaboration globally in response to the COVID pandemic, along with a significant shift in the domestic behaviour of governments, households, businesses and institutions. Important changes have occurred in behaviour in terms of the way we live, the way we work, the way we travel, the way we save and spend, and in terms of government policy response. We've demonstrated clearly that the world can pull together in a crisis. Over the next 2 days, you will hear some of the world's finest minds describe each of these threats and what we can do about them. We invite you to listen or watch carefully, wherever on Earth you may happen to be. We invite you to contribute by considering the best ways we can achieve the survival of our civilization and our species. We invite you to share the online talks of our expert speakers with family, with friends, with workmates, and with your own contacts. The modern internet and social media means that for the first time in human history, it is possible to hold a worldwide discussion. For humanity to start to think together about these risks it faces and the benefits we can reap from overcoming them. This conference and its talks will go worldwide on social media to reach everyone who is online and is concerned about their own future on an imperiled planet. Its talks will exist online for months and years after this event ends. They will be a lasting influence in favour of a wiser, safer future for all humanity. We hope that they will stimulate and inform discussion in homes and workplaces, on farms and in offices or factories, in parliaments and public assemblies, between friends and family, of what we humans must do together to save ourselves and to build a brighter future. Above all, we hope this discussion will help to translate the calls for global action into clear advice about what each of us should do and can do as individuals in our lives and our work to build a safer, more sustainable world. To solve a problem, you must have first understood the problem. Our speakers will both describe the problems we face and the ways we can go about overcoming them without making any of them worse off. I now invite you to listen to their collective wisdom and to bring your own to the task of helping to ensure the survival of humanity, our civilization, and achievements far into the future. There is no greater or more honourable undertaking. There is nothing more urgent in the entire human agenda. There is nothing more inspiring, uplifting and motivating than helping to deliver the human future. And back to you, Alpha.
Thank you, John. So, John, thank you so much for introducing the conference for us and for explaining so vividly why it matters. I would like to ask you a couple of questions. So first, you were a vibrant part of the Australian political landscape for years. You were the Liberal leader, And I noticed that in 2016, you addressed a crowd of 2,000 people in an environmental protest. And you said that climate change it should be a dominant issue and that lack of action on climate change is a national disgrace. Why do you think what you called short-term politicking is still dominant in most countries on that topic?
I think politics has just become increasingly short-term in its focus. In our country, the focus is just on winning the next election or staying in government rather than solving problems. And all the bigger issues, the bigger challenges are ignored and pushed down the road. And even when there are specific warnings, when the evidence is overwhelming on the urgency, on the need for urgent action, we don't see it. And, it's disheartening to watch this very short-term political game playing, scoring points on each other in the process, shifting blame to the other side. The bottom line is everybody's worse off, and you've pushed so much of the adjustment to the future, to future generations, that I think it's a moral failing as much as it is a broader economic and social and political policy failing.
Absolutely, I agree. It brings to mind the social contract as explained by Jean-Jacques Rousseau, which posits that individuals trade in their freedom in exchange for safety. But in a way, our governments are failing to take action on an issue that threatens our very survival. So as a politician, what do you think would finally trigger governments to take action? How can we get politicians to listen at a time when our survival is at stake?
Well, our hope with this sort of conference is that we can elevate the debate and we can get everybody talking about these issues globally, and hopefully in time that filters through to the political process. I mean, it's not easy, and it's going to take time for that to occur. But we just need to keep drawing attention to the significance of the science in all the areas that we're looking today and tomorrow, and trying to get people to understand, political leaders, policymakers, to understand that this is urgent. I guess with an adversarial system, political system like ours, where one side needs to disagree to some extent with the other, it's very difficult, because what you really need is bipartisan support. We need global agreements, global understanding. And one of the things we're hoping to get out of this conference in the end, I think, is a letter to all the governments and policymakers of the world to try and crystallise the urgency of the challenges, these 10 existential risks that are facing humanity, and recognise the consequences of pushing them down the road. The costs of inaction far outweigh any adjustment and disruption or cost of action.
Thank you so much for your contribution, and we will be talking to you again, John. Thank you so much for attending. So I'm going to move on now to introducing our next speaker, who is Paul Ehlich. Paul is Bing Professor Emeritus of Population Studies at Stanford University in the US, and the president of the Stanford Center for Conservation Biology. He is a founder of the Millennial Alliance for Humanity and the Biosphere, who are hosting this conference as well. He is a pioneer in alerting the world to the problems linked to human overpopulation and raising issues around population resources and the environment as matters of vital to public policy. And it's a great honor to have him today with us. So here is Paul's explanation on the issues that humanity faces.
It's a great pleasure to be here, although I'm not going to be talking about a particularly pleasurable topic, because what I'd like to do is tell you why knowledgeable scientists are incredibly worried about the future of civilization and what knowledgeable scientists think we might be able to do about it. The basic problem is that humanity is faced with a series of existential threats, things that threaten our ability to maintain a civilization, maybe even in some circumstances to persist as a species. And you're probably familiar with some of those threats. The one that gets the most publicity is, of course, climate disruption. We've recently in the United States had a beautiful example where the warming of the planet, and particularly the differential warming of the Arctic, has led to a weakening of the circumpolar vortex, allowing blobs of cold air from the Arctic to penetrate as far as Texas and cause great problems. And of course, we've also seen in places like Australia and California and Siberia huge problems created by a general drying of those areas as the climate disruption continues. And the mess in Texas has also illuminated what's wrong with the social system in the United States, because the moronic governor of Texas said the big problem was green energy, when in fact the big problem is in part caused by Texas's overuse of fossil fuels, which is adding greenhouse gases to the atmosphere, which in turn is warming the planet, which in turn is decreasing the polar equator gradient and leading to the big problems in Texas. So climate disruption is a big issue, although most of the discussion of it doesn't hit what's really important. People think mostly of sea level rise, which is inevitable, is going to be, it's happening now. It's going to be really horrible for people in many of the world's cities, which are right on the seashore. But it's going to be slow enough you'll be able to walk away from it. On the other hand, you can't walk away from all food. And the big problem with climate disruption is, of course, it clobbers agriculture. And anybody, and along with that, it clobbers parts of the agricultural system like pollinators that are extremely important to our diets. And you don't have to be a rocket scientist to understand that. All you have to be is a gardener or a tropical fish enthusiast. And you know, if you don't pay careful attention to the temperature, you end up with dead plants or dead black mollies or angelfish or whatever, because all the organisms on the planet, including human beings, have evolved to exist at a certain temperature range. And what we're doing is changing that range very, very rapidly. And so one of the prospects is that we're going to become much more marginal in our food supplies if we keep this rapid climate change going. And you probably know that a lot of people are hungry today, that something close to 2 billion of the roughly 8 billion people on the planet are micronutrient malnourished, which among other things weakens their immune systems and allows things like viruses to get going, and you may have heard of that also. So climate disruption is one of the big existential threats. Tied to it is what I just mentioned, is the loss of biodiversity. That is, we are utterly dependent on the other plants, the other animals, and the microorganisms of the planet for our existence, and we are wiping out their populations at a very rapid rate. Catastrophic declines in things we observe, like the number of birds in North America, but also in lots of things we don't observe, which do lots of things for us. That is, for example, the native bees that pollinate a lot of our crops and are disappearing and so on, although the average person doesn't know that they're disappearing. So climate change is one thing. Loss of biodiversity is another existential threat. Toxification of the planet is yet another existential threat, because everybody is getting dosed with a series of synthetic organic chemicals that we use for all sorts of things, most obviously in terms of loss of biodiversity, the silent spring phenomenon. We kill off a lot of organisms by overusing pesticides. We make our own lives much more tricky by misusing antibiotics, and we are using fossil fuels to create plastics, which are now jamming into the ocean, so much so that it's estimated that by the middle of the century, there'll be more plastic in the oceans than fishes. The plastics get ground up into tiny little fragments, get coated with persistent organic pollutants, that is poisons, which then can enter the human food chain, cross the blood-brain barrier, and you get little bits of poison-coated plastic in your brain. A lot of people think that was the real problem with Trump, but we're not sure. So toxification is a gigantic problem. It might help solve the population problem because human sperm counts are plummeting around the world, but it's not yet clear how far they're going to go or how fast they're going to go. But that is another potential existential problem. We're also losing our soils and groundwater, which are essential to agriculture. There are many, many threats to our entire food system. And the food system contributes in its own way because somewhere close to a third of the greenhouse gases that are changing the climate that the food system is so dependent upon actually come from running the food system. We use a huge amount of fossil fuel to grow our crops. So we spend a lot of time and energy converting oil into potatoes and doing things like that. So we have a series of really threatening problems beyond the ones that you probably thought of, like the possibility, the likelihood that there are going to be more pandemics. And we've been very lucky with the SARS-CoV-2 pandemic in that the scientific community has come together very rapidly and produced a set of vaccines, which at least at the moment seem to have the potential for doing the job and at least greatly reducing the problems with this new virus. But we're doing all sorts of things like wiping out biodiversity that in complicated ways make the chances of more nasty viruses, more nasty pandemics much larger. You want to always remember that human beings' infectious diseases come from other animals. They're variants in pathogens, viruses, and bacteria and fungi that in most cases are already present in other animals. And as you wipe out the big animals, which we're doing first, so that things like rats become more common, it turns out they're also wonderful transmitters of their own diseases to human beings. And I always remember that my old colleague, Josh Lederberg, a great scientist and Nobel laureate who invented sex in bacteria. The bacteria have been grateful ever since, but Josh once said that human survival is not preordained. That's why we have viruses. So something to pay attention to. Hopefully, the Biden administration will restore some of the things that the Trump administration destroyed that are designed to warn us of coming pandemics. The basic cause of all this has been obvious for a very long time. One way to put it is it's the scale of the human enterprise. There are just too many of us. Each one of us, on average, consumes too much, and we use malign technologies in many cases to service that consumption. And we deal with it very unevenly, which creates other problems for us. So population size, overpopulation, overconsumption, inequality, bad choice of technologies and social arrangements have produced a gigantic mess that we have to deal with. That mess is almost brand new in evolutionary terms. In other words, for most of the roughly 300,000 years that modern Homo sapiens, modern people, have been on the planet, we were small group animals living as hunter-gatherers. It wasn't until our population became large enough that people decided to start settling down and practicing agriculture that the real problems started. Agriculture and settling down, among other things, allowed a family to raise more food than it needed, and that led to specialization, to not just farmers and not just hunter-gatherers and farmers, but soldiers, priests, mechanics, scientists, and so on, which allowed us to develop a whole series of technologies, the agricultural revolution, that led then to the Industrial Revolution, which, as you can see in this list of things I've gone over, is really what's responsible for most of the existential threats. Maybe the most serious, of course, and the one that has the greatest potential for ending us as a species, is the so-called mutually assured imbecility. That is, the Russians, the Americans, and some other countries having so many nuclear weapons that if they use them, it could alter the climate and the planet so much that humanity might actually die out. Well, that's one of the great triumphs of our two revolutions, our agricultural revolution and our industrial revolution. The agri-revolution also led to economic inequality. When you had to carry everything around with you when you were a hunter-gatherer, it was hard to become super rich. And it also allowed things like slavery, xenophobia, and so on. In a summary, we're basically a small group animal that has developed a way of getting gigantic groups, but we haven't learned how to deal with the gigantic groups. We did fine when there was 50 to 100 people in each group, but subsequently things have really gone downhill. And another major thing is that we evolved our nervous systems to detect rapid changes in our surroundings. If somebody threw a rock at your head, you wanted to be able to detect it against a still background. And you can do a little test for yourself by moving your head rapidly from side to side, and you'll notice the room stays still. If you take the video on your cell phone and do this with it, and then watch the recording, you'll get dizzy, because your brain has evolved to get information from nerves that tell you your head is moving, and it keeps the background steady. So that we're very, very good at detecting a car swerving towards us, or a handsome person of the opposite gender coming towards you, and so on. But we're really lousy at seeing changes in the background because our minds were designed to keep the background steady. And one of the horrors today, of course, is what we need to do is see the gradual changes in the background. We need to see the gradual increase in temperature taken by a thermometer high up on a mountain in Hawaii. We need to register on the increasing numbers of nuclear weapons in various places. The things that threaten us, the toxification and so on, are gradual changes in our background, and we're designed to see rapid changes against a stationary background, and that makes it very, very difficult for us to adjust to the changes we have to make if we're going to survive and keep our civilization going. A small group animal just hasn't really adjusted and hasn't faced a lot of things. For example, scientists keep telling people more facts about the environment, but most people don't pay any attention to facts. They come from small groups where what they value is the opinions of their buddies, what the hunt leader says, and so on. They want to be admired by their friends, and the emotions play a huge role in our societies, which tells us that if we're going to change our behavior, which we certainly have to do, we're going to have to do a lot of things like promote soap operas with the right messages and so on, because scientists have proven that expanding on the factual knowledge of people does not normally change their behavior. They've done actual tests taking climate deniers, giving them even more scientific information about the climate, it makes them more solid deniers. And until we face that just producing the science is not going to produce an evidence-based world, we're going to continue to be in trouble, because our basic task to get out of the bind we're in is going to involve another revolution, what I like to call a survival revolution, that will be of the same scale of change in our societies, in our culture, our non-genetic information, as was the Industrial Revolution. There's a lot of things you can do individually to help protect civilization. One of the best, for example, in a rich country like ours, is have one fewer child. Having one fewer child is the equivalent of giving up driving 23 times. So there's a lot you can do individually, but actually the main chore is going to be to do things politically, to, for example, join the mob, mahb.stanford.edu, mahb.stanford.edu. It's a group of citizens trying to get together and find ways to change civil society, to make it more possible to preserve our civilization, which a lot of us think would be worth preserving. So the big task is to figure out how to do it. In other words, scientists have really pointed out what needs to be done. We know we have to stop burning fossil fuels very, very fast. We know that we have to stop destroying our soils and overusing our groundwater. We know we have to gradually lower the size of the human population, do it gradually, do it humanely. We know one of the main ways to do that is to give women equal rights and equal opportunities with men, and give everybody access to modern contraception and backup abortion. We know we have to do those things. We don't know how the hell to get them done. And that's where the social scientists, the artists, the people who are planning TV and so on come in. We're really moving from being in the hands of the biophysical scientists who have told us what the problems are and created many of the problems, to civil society trying to figure out how to get the things done that are going to get us out of this ghastly mess that we're rapidly slipping into. So I hope you will all join the mob, mahb.stanford.edu, and listen to the other people, the wonderful lineup of people that are going to be in this symposium. And I'll be happy to answer any questions. Thank you very much.
Well, that was a really inspiring talk from Paul Ehlich. So now I'm going to be asking Paul a few questions. So Paul, you first published your book, The Population Bomb, in 1968. And you explained in it the consequences of human overpopulation and its side effects on agriculture and the ability of humanity to feed itself. So it's been 53 years, and I wanted to ask you, how do you maintain your drive and keep speaking up for 53 years about a topic which, for the most part, the public doesn't acknowledge as an issue?
Well, a couple things help. One is being a loudmouth, and I don't know whether that was entirely genetic or partly environmental, but also I have a huge advantage over some of my colleagues, for instance, in demography, because what I've had to say has gotten complete and essentially total support from my colleagues. My original work in butterfly evolution and taxonomy, the person who was the leading scientist in that area when I was young, when I was an assistant professor, was a guy named Ernst Mayr, who died a few years ago at 100. And shortly he died. Another was Theodosius Dobzhansky, who was the top geneticist of the last century, and he was gone even longer ago. But Ernst used to send me holographic letters saying, "You're on exactly the right track, keep at it." Dodick was the same. I had no flack from my colleagues. And in fact, many of them signed on to scientists' warnings in the 1930s saying the same thing. Some young demographers now have to be very careful because demography has, at the upper levels, the senior people, has been polluted by what we call daydream believers. That's economists. Most economists think you can grow forever on a finite planet. And young demographers have to be very careful what they say, or their careers will be damaged. So it's been wonderful to have the full-scale support of my colleagues, and a whole bunch of us are still working together to try and get the job done. So I've been very, very fortunate, lucky in my career, particularly because of the support of my colleagues.
That's wonderful. I also noticed that at the end of the 60s and the beginning of the 70s, overpopulation was flagged as an issue and understood to be an issue by very eminent people, such as, for example, Martin Luther King and others like him. But over time, it has sort of acquired a reputation for being a false issue, something that is a red herring that shouldn't be discussed. So why do you think there was this evolution in the way we collectively think about overpopulation? And do you think the pendulum could swing again? And what would it take for awareness of this issue to come again?
I think the pendulum is beginning to swing back in the other direction already. The reasons are, I think, pretty obvious. First of all, there was great concern about, first of all, let me say, the original title for the population bomb was Population Resources Environment. But the publisher said it'll sell better if you call it population bomb. And so I became known as the population bomber, even though actually the reason that I emphasize population in the book is that one of my heroes was Rachel Carson. I only met her once, but I was very concerned. My original research when I was studying for my PhD was on the evolution of DDT resistance in fruit flies. And of course, in the population bomb, we talk a lot about that. But then, first of all, there were the racists, which I had hoped we had damped down in this country until at least the Reagan era, but who said, yes, Ehrlich says there's too many people. Here's the kind of people we want to get rid of. And that's something that people concerned with population have had to face for a very long time. Because, yeah, there are too many people, but there are not too many poor people. There are too many rich people. And there's not too many people of any given skin color or any different ethnicity. There's just too many people consuming too much. And what we need to do is get everybody to have smaller families and get everybody basically with the same standard of living. That is, you need redistribution, not growth. And that's slowly coming back. But we've had, particularly during the Trump administration and still continuing, a resurgence of hideous racism in our country. And it's been a concern of mine for my entire life. I had my life threatened desegregating restaurants in Lawrence, Kansas by group action when I was a graduate student. And we need even more of that today. And I think if we're going to solve these problems, we need the young people, all of them, to get out there and do things. And I was very pleased, for instance, with the Black Lives Matter movement. You're not going to get the high-level politicians who are entirely owned by the people who donate to them in most cases to lead the way. We got to get really smart young people, as we have seen in climate, leading the way.
Absolutely. So during your talk, you mentioned a really interesting concept, that it's not possible to convince someone with more data. And you also mentioned that as a species, we have evolved to detect rapid change so that we don't actually see background changes. So it reminded me of Yuval Noah Harari's book, Homo Sapiens. in which he explains that our ability to transition from small bands of hunter-gatherers to large civilization rests on our ability to create what he calls myths and what I'll call narratives. So to change the narrative about who we are and what we are here to accomplish. So change and progress seem to be directly linked to the stories we tell ourselves about ourselves as a species. In what ways do you think you would like to see our narrative change? What stories and myths do we need to create now in order to trigger change?
Well, first of all, Harari picked up the thread very nicely. It's one of the better summary books that I've read on the topics. And I think you can look at the example, for example, you're talking to an old man. What can you expect? But the Population Media Center run by Bill Ryerson gives examples of the following sort. They'll go and do a survey in a country about attitudes towards, say, women's rights and abortion. And then they'll run a soap opera for 10 weeks or something, in which it's an exciting soap opera. It tells you a lot of stuff, it keeps you on the edge of your chair, but it also has a theme that emphasizes the directions we think that people's attitudes ought to go. And then they run surveys afterwards, and it finds out that attitudes have changed. And we see the impact. One of the nice examples in my mind of some single picture that changed humanity dramatically was the first picture taken of Earth from outer space. The little blue dot picture, basically, except blown up. And that really brought home to people something that the ecological community had been emphasizing since around 1950, and the whole community, the fact that we're a global society, that we are an isolated single mass, and the kind of big level questions we're going to have to start asking if we're going to move in the right direction is things like, are borders ethical? The resources of the planet are randomly distributed. When you hear lines like, how did our oil get under their sand? You can see that the nation state system is not the way to successfully run an entire planet, which is what we have to do. So I'm blithering on. Ask me another question or pass it on to somebody who knows what they're talking about.
I think, actually, I just made a note. Are borders ethical is a fascinating question. So I must also ask you questions from our participants who are kindly writing them down in the chat. And we have a question from David Barash, who mentions, you explained the concept of humanity being geared, our brains being geared to detect rapid change as opposed to slow moving change. And so David is asking that how do you deal with the two happening together? So he mentions, for example, slow-moving disasters such as a global heating, and at the same time, potentially extremely fast change like a nuclear strike. And how do you reconcile the two happening in tandem? And how would we be able to deal with both levels of threat and dedicate our attention to both types of threat and at the different phases they're happening?
In my view, you're doing exactly what needs to be done, but on a much larger scale. That is, questions like, are borders ethical? I think the people who think about it understand that's a really big question. And when you look at what's happening to migration in the United States and what's going to happen, and it's already happening in some places around the world in migration, these are gigantic issues that basically aren't discussed in the public media or in the public. We don't discuss ethics very much at all. Stanford University has a war criminal running one of its big institutions, and nobody seems to worry about that. So we need much more public discussion, which is exactly what this symposium is trying to generate, what the mob tries to generate. People have to start, first of all, scientists know they don't have the answer to many things. And my biggest worry when I was, say, 12 years old was that scientists would discover everything and understand everything before I had a chance to become a scientist. It was the most ridiculous worry I've ever had. We live in a world of uncertainty. Scientists are all very aware of that, but the public doesn't know how to deal with it, and they don't discuss how to deal with it. And it's something that everybody has to decide on. We are stuck with each other. We're stuck with a very large population, much larger than we'll ever be able to sustain over a long term, unless there are miracles in science that the scientists have not thought of yet. But it looks like our knowledge is good enough to know that nobody is going to produce, say, a way of recycling energy, which would demolish one of the most basic laws that have been proven everywhere in the universe. Yeah. What we need is much more discussion, much more people aware of it, changing the curriculum. And for instance, in major universities, if we changed our curricula to deal with the existential threats, that would feed on down to the L-high system, at least in the United States, because most of the problems that are going to be discussed in this symposium are easily understood by middle school students. In other words, the science is not that super special and super complicated. You don't have to know rocket science to know the more people you have producing the more greenhouse gases, that you're going to have trouble with your agriculture because you're going to change the temperature. And every time you've planted plants in your backyard that were tropical and you've had a winter, guess what happens?
Absolutely. So one last question from Ashley Colby, who mentions that she's a former student of your old friend Jean Rosa at Washington State.
Oh, yeah.
She asks, what can you name as small-scale solutions that could be adopted worldwide that really excite you? And she says, actually, there are things that she finds exciting, like, for example, advancing more small-scale agriculture and homesteading, repopulating rural areas. Are there solutions of that type, small-scale solutions that you think are promising and would be good to apply?
There are all kinds of small-scale solutions that we can all take part in. Little economic systems like giving loans to women in poor countries. Turns out women are smarter than men and very able to do wonderful things with a little bit of financial support. That's a small solution, and there are all kinds of small solutions. Eating less meat is a small solution. Not doing more walking and less driving is a small solution. But the thing that we have to remember is the level of small solutions give us clues about what ways we could go and what ways we can change our behavior. But in the decade or so that we may have left to really do something, at the very top of the list has to be political action. It's collective action is the way to go. But small solutions can make your own life better. And small solutions can actually move things more rapidly in the right direction. I mean, for example, I have discovered that drinking fermented grape juice keeps my internal environment in great shape while I consider what's happening to the external environment. I think 45 Mouton is the best of those in grape juices you can try.
Okay. Well, thank you so much, Paul. It was a pleasure to have you. And thank you so much for all the work you're doing to save humanity from itself.
Very nice to meet you.
All right. Same. All right. Thank you so much. So now we're going to move on to Dr. Swaminathan, who is the chief scientist of the World Health Organization and is globally recognized for her work on HIV and tuberculosis. She is a pediatrician and a clinician who has served in many leading roles in health science and research, including as a Director General of the Indian Council of Medical Research and Secretary of Health Research in India's Ministry of Health and Family Welfare. And she's going to give a fascinating talk about pandemics and the future of global health and the consequences that we can infer and deduce from the pandemic that we are still living through. So here is Dr. Swaminathan.
Greetings from the World Health Organization. I'm Dr. Swaminathan. I'm the chief scientist here, and I'm so honored and privileged that I can share some of my reflections with you all, discussing the future of global health and what the pandemic has taught us. It's been an absolutely tumultuous year. It's been extremely challenging, and it's also been gratifying but humbling as well, because as the year went on, we realized that we knew very little about this virus. At the beginning of 2020, we kept learning more and more, and I don't think we're finished learning yet. And so while the science has really evolved at an unprecedented speed, and we're actually in a position where we have vaccines available within 12 months of the discovery of a new virus, and that's an amazing testament to science, there are still knowledge gaps, and there are still things that we have to learn about this virus, which will help us as we try to come to an end, bring an end to this pandemic, but also prepare for the future. And today I want to be able to reflect on some of the lessons that we've learned and what it means for countries, what it means for politicians, for policymakers, but also for communities, for individuals, as we try to rebuild our lives. And the first thing I would say is that the pandemic, apart from the fact that it's infected close to 120 million people and killed over 2.6 million people around the world, and these are just the known and documented cases and deaths. We know that this is an undercounting, both of infections and of deaths. There are so many impacts and shocks felt by people not directly related to getting ill from COVID and dying, but really the impacts on livelihoods, on education, and particularly I think about the impact on women and children in many countries, and we know that violence against women has increased, that people have been pushed into poverty, and that inequities around the world have been exposed in every country. So it's within every country and between countries. We see now the glaring gaps in people who are able to cope and manage their work and not lose their jobs, and those who were already just on the edge, just about surviving, and have now been pushed off that. And there's a huge uncertainty that lies ahead for them. I want to start by reflecting on what happened to health systems around the world. And we saw that there was really no ideal health system that was able to cope with this kind of a shock. And particularly surprising was the fact that so many high-income countries that have very sophisticated health systems, that have excellent hospitals and doctors and specialists and intensive care units, seemed to bear the brunt and seemed to have the highest case fatality rates and the largest number of deaths. And the gap there, I think, has been in the public health workforce and system, which has got eroded over the years in many of these countries. On the contrary, the lower middle income countries, which do not have the most sophisticated tertiary healthcare services, many of them have invested in community health programs and primary health care. And because they're used to infections, used to dealing with tuberculosis, with malaria, and with HIV, they were able to perhaps do better with things like case finding, contact tracing, making sure that people are provided supportive isolation and quarantine facilities, setting up some social support networks, and so on. The countries in East Asia, which had been through SARS-1, actually, many of them learned their lessons and had really geared up their health systems to deal with this type of infectious disease shock. And countries like Vietnam and Singapore and Hong Kong and Japan and Australia and New Zealand, we saw that the response, and China, was very aggressive. It was early. It was well thought out. It was based on the knowledge of how the virus behaves and what's needed, did not necessarily involve large, prolonged nationwide lockdowns, but focused on the essentials of being able to test and trace and track and quarantine and isolate and keep the virus transmission down at very low levels. Now, the WHO did a survey of countries in the middle of last year to see what happened to health systems. And we found that 80% of countries that came back and reported back to us said that their essential health services had been disrupted to some extent. And this was felt most acutely in the low-income countries because you already have a stressed health system with a limited workforce. Many countries do not have enough doctors. They rely a lot on nurses and community health workers, and they were completely overwhelmed by having to take care of COVID. So things like immunization services, antenatal care, treatment of non-communicable diseases, cancer, all of these suffered, including things like essential surgeries and blood bank services. And so there is a fallout beyond just the COVID, which the impact of which we are still haven't fully measured, I think, in many countries. So really the lesson there is that you need resilient health systems in terms of a workforce, in terms of supply chains, in terms of data systems, in terms of having people at the sub state level, at the lowest level of administration who understand epidemiology and disease control. And of course, you also need a well-functioning administrative support system that can provide support to the public health actors and specialists at a time like this. Now, we've seen beyond the impact on health systems, the impact, of course, on livelihoods that we talked about. We know that the global economy is going to contract, by a huge 4 to 5% in 2020. It's estimated another 130 million people will go into poverty. And we know that the Sustainable Development Goals, our attainment and the path to that is going to be derailed unless policy actions are taken very quickly, especially in favor of the poorest people, because global poverty is on the rise for the first time since the 1998 Asian financial crisis. In 1990, the global poverty rate was about 36%. It had come down to 8.6% by 2018, but it's likely that that's already risen and will continue to rise through 2021. The majority of workers in Africa and other the least developing countries, over 80% of workers do not have access to any social protection. And therefore, the economic fallout is likely to last well beyond the health crisis. Global human development as a combined measure of the world's education, health, and living standards is on course to decline for the first time in 30 years. And it's clear that the pandemic has shown that development is no longer just going up the ladder. The direction has changed. And based on the socioeconomic impact seen across countries, the recovery path must include a new human rights-based, just and fair social contract between governments and the people. We need to advocate for social safety nets with a broader reach, universal health insurance and health coverage, affordable access to digital connectivity. We've seen, again, the digital divide between those who are able to continue to work and to school using online access and a large number of the world's poor who were not able to access those services. We need global collaboration and solidarity for an effective response. And again, we need to focus on the basics, make health as a human right, ensure that health is a priority for investments by every government, and that universal health coverage is the only way out to prosperity, really, because without good health, there is nothing else. And I think the pandemic has shown that extremely clearly. So investing particularly in primary healthcare services, in good surveillance systems, in a good, well-trained workforce, in sustainable financing for the health system, which can be increased at the time of such shocks in supply chains, and very importantly, also in community engagement. Health systems where communities are engaged and empowered to act have done much better than health systems where there's only been a top-down approach to solving the problem. The other area I'd like to touch on is on global innovation and research and development. Now, this, I think, has been the silver lining. The boost that science and technology and innovation has received during this year, the unprecedented speed at which new products have been developed, new diagnostics, vaccines, in 314 days between the public availability of the whole genome sequences of the SARS-CoV-2 virus and the first vaccine receiving regulatory approval for use. I mean, this is completely, nobody in their wildest dreams would have thought it possible. The number of diagnostic tests that have now become available, where you now have rapid diagnostic tests, you have self-testing kits, a whole range of diagnostics compared to the same time last year when there was very, very limited molecular testing available. We've seen a huge number of academic, private, and public collaboration, partnerships, and initiatives, all directed at developing technologies that can help with the pandemic. There are probably 3 innovations that stand out here, which will be important for the future and for other diseases. The first is the development of the platforms for vaccines, the mRNA platform and the viral vector platforms. These have happened because of consistent investment in this area of work over the last decade or so, and they have proven to be highly successful. mRNA vaccines in particular can be very rapidly engineered, both to deal with the new variants of the virus as they emerge, but also for diseases like tuberculosis, where we've failed to really produce a successful vaccine. HIV and malaria are the other diseases that really could do with a good vaccine. So we can use these new platforms. As I mentioned, diagnostics, again, a huge amount of innovation, rapid diagnostic kits and paper-based diagnostic tests. I wish we had these for other diseases as well, that could be used, at the level of the primary healthcare clinics. Antiviral drugs, there's been very little progress and investment in this. And now there's, again, a renewed focus on developing antivirals, preferably broad spectrum antivirals that can be used to treat SARS-CoV-2 infection, but also other viral infections that could emerge. And so this renewed interest and the global focus on solving some of these big global health problems could provide us a permanent infrastructure that provide major benefits to future generations. But we have to do it wisely, we have to learn from the lessons, and we have to think about a new paradigm. The private sector, we've seen them stepping up in many ways. Without the private sector, we would not have seen the vaccines in the millions of doses that we have today. Of course, we need more. We don't have enough supplies. And we've had a lot of the private sector groups, the World Economic Forum and the CEOs and so on, talk about this idea of stakeholder capitalism. I think we need a new model of R&D for goods that are global public goods. And I think many people would consider vaccines to be global public goods. And this is where we need to put that above the profits of individual companies. We need to think of a model where a new innovation or a technology that's been proven to be effective against a disease is then, we use all the opportunities possible to scale that, to transfer technology to other companies around the world that can manufacture, and to make it available to people around the world, especially where the disease is posing a huge burden, so that we can actually solve that public health challenge. We're testing this now with the SARS-CoV-2 vaccine and with the establishment of the ACT Accelerator and the COVAX facility. For the first time, we have a global facility and a mechanism to promote the development of a broad portfolio of vaccines against this virus, but also to ensure equitable and fair access. This has not happened in the past. I think the COVAX facility is already now rolling out. We've rolled out over 30 million vaccines in the last 2 weeks to about 35 countries. And over the course of this year, the COVAX facility will provide at least 2 billion vaccines to 190 countries around the world. That's a model that should be kept alive for future pandemics and health shocks. The linking of the R&D, so it's an end-to-end. The investments in R&D must translate into products that are then provided at an affordable cost for people around the world, regardless of their ability to pay. So I think we are getting closer to that ideal, but we're not there yet. It will require the cooperation and collaboration between governments, between the private sector, between the shareholders of those large companies, between smaller manufacturers in parts of the world like Africa and Asia and Latin America. If you look at vaccine production today, you see that there are differences between these regions. And to promote regional health security for the future, we need to ensure that both diagnostics and vaccines for emerging diseases can be produced in every continent, so that you have the local capacity and you don't have to depend on very complex global supply chains and the charity of others, because this is not about charity. A pandemic cannot be solved one country at a time. I think we have to recognize, as can other threats like climate change or antimicrobial resistance. These are global threats which challenge us as a humanity, and we need to find global solutions by working together. So to conclude, I would say that governments, civil society, private sector, all have contributed to ending this pandemic and have learned lessons. We now recognize that every government sector would need to be involved in this outbreak response. The health department or ministries alone cannot solve this problem, because it goes way beyond that. So you need what we call an all of government, all of society approach. You need multi-sectoral action. You need early, widespread and accurate communication of information, including what is not known. The science has been evolving and changing, and in fact, this is an opportunity. The first time, I think, that you've had science on the front pages of newspapers and television channels almost on a daily basis. And this has given people a window into how science works, but it's perhaps also confused them, because things keep changing. And some people interpret that as, oh, these scientists don't know what they're talking about because they keep changing their mind. But I think that's where we need to build the understanding that that's how science works, that you have to change your policies and your approach as your understanding of the disease improves. We need to communicate early and often. That's what the WHO has tried to do with accurate information. And we need to manage what we call the infodemic, which is really this huge explosion of information that's become available to people. A lot of it is misleading and untrue. And we need to be able to help people to differentiate between credible information and false information. Communities must be engaged from the beginning. It has to be a bottom-up approach, not a top-down approach that will work. We need to engage the entire range of experts, including social and behavioral scientists. It's not enough to have only a biomedical approach. When you're talking about behavior change at this scale, you need the behavioral insights and you need the experts to inform the policies. I've spoken about the importance of investing in public health and primary health care. The role of science, scientists, and public health specialists has become very, very obvious and clear, and we need to invest in those institutions, including the regulatory bodies and countries which have also played such an important role. We need to improve global collaboration on research and development, particularly for products that will help solve our big public health challenges. And as I said, it's not only about infectious diseases. We have other global challenges to our health, to the population that we need to solve. And then the importance of genomics in all of this. Some of these cutting edge technologies has become quite apparent, especially as we see the evolution of the virus, the emergence of variants and so on. There are many countries that don't have these capacities as yet. So again, we need to work as a global community to make sure that every country in the world has the surveillance systems in place, because otherwise we cannot prevent future pandemics. A pandemic can arise anywhere. And I think it's a question of when and not if the next pandemic will be upon us. And so we really need to prepare. We, of course, have the independent pandemic preparedness panel that's looking at this, and will have a report by May that will lay out a roadmap for what needs to be done. But we can already start thinking about some of these things. And finally, I would say that, political will and political leadership has been extremely important and critical in building trust, in community engagement and empowerment, and in addressing the societal inequities that we still need to do for the future in order to build a more just and healthy society. Thank you so much for this opportunity.
So quite an interesting talk from Swaminathan. So I think there may be a technical issue. Soumya, are you on this call? All right, so she's encountering technical issues, and we'll try to solve them. So in the 10 minutes that we have for the Q&A, what I'm going to propose is that instead of asking Soumya the questions, I'm just going to open the floor to everyone and ask you the following questions. So during her talk, she asked a very interesting, she made a very interesting point about a new paradigm beyond private profits, where we identify global public goods and where we work together to make them available. So, we can contrast this with the COVID response of most wealthy countries, which are in a way keeping all the vaccines for themselves and for the most part, with the WHO urging wealthy countries to share with less fortunate countries that may not have the means to purchase all the vaccines. So I'm asking this to the group. How likely do you think it is that we'll work together to in the future prepare for pandemics together and consider global public goods as something that we are all going to share? And under what conditions would it work, and how would we usher that era in? So the question is, how likely is it that we're going to consider vaccines to be global public goods, and how do we go about sharing them? Does anybody have a view?
Right before I jumped on this Zoom, I was on Twitter and saw footage of London of thousands and thousands of people marching maskless, and, saying we want our freedom back, and, just COVIDiots that don't believe in the virus. So I have to say, having seen that right before entering this Zoom, my hopes are not up.
Oh, that's so interesting, Leilani. Thank you for your contribution. Yes, and I think there's something about the infodemic that Soumya also mentioned. What an interesting word. So information pandemic, infodemic. And she mentioned that the WHO identified this as a threat to our ability to manage the next pandemic, or even this one. So when you mention all these people protesting because they don't understand the virus or they don't believe in it, it's probably because of the issue that was highlighted in a Netflix documentary called The Social Dilemma, where they explain that essentially people have access to different information, and we no longer have a common denominator or common ground for our information. And so it becomes extremely difficult to solve problems together if we cannot agree on what constitutes the problem or what constitutes the truth. So does anybody have views on how this infodemic is going to impact our ability to manage future pandemics? Sean Turnbull, it looks like you want to say something?
Yes, I think there's great hope in that the biggest asset manager in the world, Larry Fink, that manages BlackRock, wants all corporations to benefit all their stakeholders, and he got the US Business Council to support that objective. And if corporations are promoting the common good for all their stakeholders, then they are promoting global common goods, which could include the questions that you raised. So we have big business on side, just a matter of making him to walk the talk.
Yes, absolutely. I think that's actually part of the solution and part of the problem, because big businesses is usually for profit. So they are on board as long as it allows them to make a profit. But if we start talking, like Souyma was talking earlier about global public goods, how do we make that work?
Introduce a tax incentive. Very simple. It's irresistible. If they think their job is to maximize profit, then give them a tax incentive so that they change their corporate constitutions to endow their stakeholders with their ownership over the life of a patent. And the big institutions who would have a fiduciary obligation to vote for changing the constitutions of companies to get a bigger profit quicker with less risk, on condition that the stakeholders are the beneficiaries of the endowments. And you'd create a global universal well-being income, and that by spreading capitalism, you would democratize capitalism and spread it around the world. So you solve the problem Murik was talking about as the inequality, and you'd solve the problem that CEOs would be promoting, would be committed to promoting the public good because they'd be representing their stakeholders.
Okay, that's really interesting. Paolo, would you like to ask a question? Also, I should mention Paolo is one of the organizers of the conference today, so welcome.
Thank you so much. This is always, in these questions, is always the first step when we have a common problem is to define the common good itself, the first step, and second, to create rules, congruent rules between the provision of the public good and the appropriation of the public good. This is the problem, for example, in climate, that we haven't defined yet, that, for example, climate is a common good, and without making this legal background, accepting that we have a common good that exists inside and outside all the boundaries, we will never provide the common good in a global scale. And the same thing is on pandemics. I think that this type of diseases should be something like a concern, a common concern, a global public good, and all the medicines, all the vaccines should not belong to, they should have one agreement between the private and the global institutions to use and to provide this global public good. The private cannot have losses, but cannot make so huge profits once there is a deeply connection between all the planets. This problem will not be solved in one only country, so we must have a system, a global system, to as soon this type of diseases start in one country, we must have an international system to start to intervene the problem, because this is a global public good. And the damage are global, are not only local. So we have the big change, I think, we have in this century is to redefine what are the global public goods, what are the global commons for our future. Without making this step, we can have all the technologies, we can have all the money will only be in some countries, but the problems are the others, and when they are in the other countries, we have always a global problem. Is to rethink the system and to accept comments.
Thank you, Paolo.
Thank you. Thank you.
Ashley, I believe you have a question. Ashley Colby?
Yes, I was just responding to Dr. Swaminathan's comments, and maybe this could be just something we discuss generally among the group, but I'm wondering if we can talk about the positive effects of relocalizing supply chains. Something we noticed during the pandemic that's also something we know as environmentalists is global supply chains are a huge disaster. So I'm just wondering what people think about localizing supply chains, either as local as possible or bioregions, and then obviously keeping some things at the global scale. That's okay, but just thinking about scale in general, about how our economies run, could sort of solve some issues that are overlapping.
And are you talking about specific supply chains, like vaccine supply chains, or food, or what kind of supply chain?
I don't know enough about vaccines to say vaccines, but I'm just thinking, like, what are the things people need the most of? Those should be created as close as possible to where they're consuming. So food first, and goods that can be made locally, and then out from there, some things that are less and less used on a daily basis could be further and further away. And I'm wondering if anyone's thinking about relocalization here in this group.
Thank you.
I can speak to that for just a moment. When I was working on my first book, which was about 25 years ago or more, I noticed that it was very obvious that where people had short local supply chains, they could immediately see the results of whatever it was that they were extracting, how it was affecting the resource, and they were much more responsive to any degradation or declines that they were causing because it was affecting them much more immediately. Often they were affecting it themselves because they were part of that supply chain. But the farther away that the supply got from the demand, the more the supply would just move around and create serial depletion or serial destruction of the resource. So I think, Ashley, just to say, I think that you put your finger right on a major problem there.
Excellent. Well, thank you so much, everyone, for participating in this little impromptu debate. I think it was very interesting. All right, so without further ado, let's move on to Peter Glick. So Peter is Director Emeritus of the Pacific Institute with a focus on the environment and global sustainability. He is an international leader, innovator, and communicator on global water and climate issues, and a member of the US National Academy of Sciences. Dr. Glick's work has redefined water from the realm of engineers to the world of sustainability, human rights, and integrated thinking. He has pioneered the concept of a soft path for better managing the world's water. And his speech today is about global water scarcity.
Welcome. My name is Peter Glick. I'm delighted to be able to offer a presentation to you today about, in my case, the issue of global water resources. And I'd like to thank the organizers of the conference for inviting me to participate. When we're done, hopefully there will be an opportunity for a little bit of back and forth, perhaps some Q&A, but we'll see. Let me begin by sharing my screen here. I'm going to talk about the world water crisis. Many of my comments will be relevant for other resources as well: energy, forestry, agriculture, biodiversity. My focus and my experience is on water and the issue of climate change. Water is connected to everything we care about, and I'll use it in a sense as a proxy to talk about global resources in general. We live on a water planet, but very little of the world's water resources are fresh. Very few of the water resources on the planet are available and accessible to humans. That big blue dot is the total volume of water on the planet. The smaller blue dot is the amount of fresh water on the planet. And it's a tiny fraction of the total water available, and even a tiny fraction of those water resources are accessible to humans. What I'll be doing is describing the nature of the world's water problems, and I'll also describe a path forward to solve them. In terms of the global water crisis, there are many pieces to this, of course, but for me, the most serious, the worst, and in many ways the most inexcusable problem is the failure to provide safe water and sanitation for billions of people. It's the 21st century, and yet huge numbers of people on the planet still lack access to the most basic fresh water and most basic sanitation services. And these people live in what we describe as water poverty, the result of society's failure to spend the money required to apply technology that we well understand and to make the fundamental commitment to provide safe water and sanitation for all. Among the worst consequences of that failure is water-related diseases. There are millions of cases of preventable water-related diseases every year: cholera, dysentery, parasitic diseases like schistosomiasis and guinea worm, and millions of cases of preventable deaths, many of which are children under the age of 5. But this isn't just a problem in developing countries. Even in the richer countries of the world, we have populations without access to clean, safe, affordable water. This is Flint, Michigan, where thousands of people were exposed to lead and other contaminants after a failure of the water system and the failure of their local governments. And this isn't just a problem in cities. In California, hundreds of thousands of people lack access to safe water and sanitation, almost all in disadvantaged, primarily Latino communities in the Central Valley, exposed to agricultural chemicals, high salinity, and again, a failure of governments to provide safe and affordable water services that most of us take for granted. Another part of the world's water crisis is the massive contamination of our freshwater systems with industrial and human wastes. The start of the environmental movement in the United States was in part to protect water resources. Here, the Cuyahoga River catching fire in 1969, which captured the imagination of the American public. This is actually a photograph from a previous incident when the Cuyahoga River in Ohio caught fire in 1952. But these kinds of incidences led in many ways to the public movement for clean water in the United States. It led to the passage of the Clean Water Act and the Safe Drinking Water Act in the 60s and 70s. But even those efforts to clean things up failed to solve our water problems today. Even today, we have toxic algal blooms. We have new drinking water contaminants appearing in Lake Erie, for example, again, where the Cuyahoga River ends. Of just a few years ago, a problem with toxic algal blooms led to the closure of the water supply for the city of Toledo, Ohio. And we continue to have serious water quality problems around the world in different forms, in different places, and at different times. Without water, we don't have food. 80% of the water that humans use goes to the agricultural sector, and a substantial portion of these water resources come from unsustainable groundwater overdraft. By some estimates, 30 to 40% of today's production of global food comes from water resources that come from unsustainable sources of groundwater overdraft. This cannot continue. And yet we have to grow more food for more people in the future, or get better about what we grow and how we grow it and where we grow it, and how the world's food system delivers what we grow to hungry mouths. In many ways, the food problem we face is itself a water problem. And many of our worst ecological problems are associated again with our use of fresh water. Freshwater ecosystems cover less than 1% of the Earth's surface, but they contain a third of known vertebrates, including 40% of fish species around the world. The Freshwater Living Planet Index, a measure of the health of freshwater ecosystems representing nearly 3,400 species of birds, fish, amphibians, mammals, and reptiles, has declined by 83% since 1970, a collapse described by some as catastrophic. 80 different freshwater fish species have gone extinct, and disturbingly enough, 16 of them in just the last year. Another indication of the incredible importance of fresh water for ecosystem health and biodiversity, and yet the vulnerability of our ecosystems to the way humans take water out of those freshwater systems. Water is also a political issue. Half of the land area of the planet is in what we call an international river basin, a river shared by 2 or more countries. Growing water scarcity means growing tensions over water. And this graph comes from the Water Conflict Chronology, an open source database that we maintain at the Pacific Institute, showing recent trends in water conflicts around the world from 1980 up until 2019. And it shows, first of all, a tremendous increase in the number of water conflicts that occur each year. But it also shows the kinds of conflicts that we're seeing. Conflicts started where water is a trigger of conflict, the blue chart, or where water targets, are targets or casualties of conflict in red, or where water systems have been a weapon of conflict in green. And in all of these cases, we see a dramatic increase in the number of conflicts over water resources in recent years. And of course, we know we're changing the climate. The science is strong. Every professional scientific organization on the planet, every National Academy of Sciences on the planet acknowledges that humans are changing the climate. Other talks here will focus on the issue of climate change in much more detail, but let me note that among the worst impacts of human-caused climate change will be impacts on water resources, changes in water availability and quality, changes in rainfall events and evaporation rates as temperatures go up, changes in extreme events, including floods and droughts. And this isn't a future problem. This is already a problem for today. These impacts are being observed as already. And there's another piece to this as well. Water is very closely tied to energy. It takes water to produce the energy we use. It takes energy to produce and clean and distribute the water resources that we use. And we must reduce the energy and greenhouse gas footprint of our water system, while also preparing to deal with the now unavoidable consequences of climate change. Those impacts we can no longer avoid. As a note in this area, natural catastrophes are on the rise. This is a graph that shows the total number of natural catastrophes worldwide, broken out by hydrologic events, those related to our water resources, meteorological events in green, related to extreme weather events like floods and droughts and storms, climatological events, and then at the bottom, geophysical events. The vast majority of these natural catastrophes are in some ways related to both the climate and to our water resources. Swiss Re, which provides these data and is one of the major reinsurance companies on the planet, notes, quote, "The only plausible explanation for the rise in weather-related catastrophes is climate change," end of quote. But let me also talk in the context of dealing with the global crisis around water to the issue of solutions and what I call the soft path. I'd like to offer some thoughts about how we can solve our water-related problems. My work has focused on defining what I call the soft path for water, a new way of thinking in an integrated way about tackling freshwater challenges. There are many components of this, but part of the key point here is that there is an alternative way forward. There is a way to solve our water crises and to move forward to a more sustainable future. And let me describe what I mean by the soft path for water. The hard path, which is the way we have dealt with water in the past century, is build for water supply, find more water supply, take more water out of our rivers, out of our ecosystems, out of our groundwater systems, and build hard infrastructure. The soft path says rethink water supply, find new sources of water, new sources of supply that don't require more damaging extraction of water from our natural ecosystems. The hard path said satisfy projected demand, find new sources of supply to satisfy some assumption about ever-increasing demand for water. But the soft path says rethink water demand. And I'll talk about this in a little more detail. The hard path says water is an economic good and only an economic good. But the soft path says water is an economic good and a human right. The hard path says build centralized water treatment systems and produce only one quality of water, potable water, when the soft path says protect water quality and match the quality of supply to the quality of the need. We don't need potable water, for example, to water our lawns. We don't need potable water quality to flush our toilets. And some might argue we don't even need lawns at all. But match water quality, the quality of the water that we have with the quality of the water that we need. The hard path gives no thought to ecosystems, to ecosystem water needs, or to ecosystem health. The soft path says protect ecosystem needs, protect ecosystem health. And the hard path is a path where we have centralized management and limited public participation. But the soft path calls for community participation about how we manage our water resources, flexible water institutions. These differences are critical for moving forward. And here's what they mean. They mean provide for the human right to water. And think about water not just as an economic good, but as a human right. The UN declared a human right to water in 2010, and we're making progress on meeting water and sanitation goals under the Sustainable Development Goals. But we must do much more to provide safe and affordable water for all. The failure to meet basic needs isn't a technology problem. It's not an economic problem. We know how and we have the money, but we have failed to mobilize the resources. We need to think differently about supply, not new demands, not aqueducts, not groundwater extraction, but wastewater treatment and reuse, stormwater capture, and appropriate desalination. We have to rethink water demand. We need to be much more efficient in the way we use the water we're already extracting from the system. There's a massive opportunity to improve the efficiency of water use. Let's produce more of what we want with less water. And this is true for agriculture. Let's grow more food with less water, with improved irrigation efficiency, improved soil moisture monitoring, improved crop choices. We must acknowledge the value of ecosystems, even when our traditional economic system has failed to do so. For water, one approach is the restoration of natural flowing rivers, including guaranteeing minimum flows and removing dams. This is the Elwha Dam on the Elwha River in the Pacific Northwest, the largest dam removal project in the United States. And this is that river after that dam was removed in 2014 and 2015. And salmon fisheries on the Elwha River are now being restored. And we need better institutions. We have to change our institutions. Nelson Mandela said in the context of water, quote, "It's one thing to find fault with an existing system. It's another thing altogether, a more difficult task to replace it with another approach that is better." That means managing our water resources and our energy resources and our biodiversity systems with different kinds of institutions, managing for sustainability, not for extraction, for equity, not for exclusion. Some final thoughts. The freshwater crisis is real and it's bad. There are human, economic, and environmental costs to inaction. Not everything is getting worse, and we need new thinking. We need solutions that are sustainable, scalable, and socially responsible. We need new technologies or better application of existing technologies. We need better economics or better application of economics. And we need smarter, more integrated institutions. And finally, new actions, commitments, partnerships, and communications and outreach can move us in the right direction. Thank you very much.
Thank you, Peter, for this really interesting talk about water. So I'm going to ask you a couple of questions now. So the first question I'd like to ask is about the system that we live in. So in The Big Short in 2015, a film about the subprime market crisis, we were introduced to Michael Burry, who was the investor who detected the problem years before the financial crisis happened. And it is revealed at the end that this person, Michael Burry, is now investing, focusing all his trading on just one commodity, and that's water. So as water becomes more scarce, do you think the capitalist system in which we live will also assign more value to it? And what are your thoughts on this? Is that a good thing or a bad thing?
Yes, thank you very much. So people keep telling me to watch that movie. I haven't seen it, but of course the idea that water is increasingly a commodity, it's no longer a public good, as in fact we had a little conversation right before this about how to make some of these goods more public versus private, but is increasingly a private commodity is a challenge. And of course we saw this with bottled water, where private companies have managed to turn a public resource into a private commodity and sell it back to us at an enormous markup in price. And I think that's part of the challenge. We have to understand how to balance the idea that water is an economic good, that we pay for water services. I want tap water of incredibly great potable quality coming out of my tap. I want my wastewater magically taken away from me when I flush the toilet. And I'm willing to pay for that. But at the same time, water is literally a human right. As I mentioned in my talk, the UN declared a human right to water in 2010. We're not quite sure how to implement that. But it's clear that the failure to meet basic needs for fundamental water services, for safe, affordable water and for safe sanitation systems is not available to everyone worldwide and should not be a requirement that there be an economic cost, that people have to pay for that because for reasons of poverty, they're unable to pay for that. So balancing this water is an economic good. It's a service we should be willing to pay for, and yet it's also a human right, is one of the challenges in moving forward to a more sustainable system.
What an interesting dynamic between the two concepts. So I really thought that your soft path to water was a really interesting concept. And when you did mention water as a human right, did you envision that it would be individual governments' responsibility to provide adequate infrastructure to their population, or do you envision a different model?
Yeah, so that's another great question. And interestingly enough, it gets back to the conversation we were having right before this. I talk about the global water crisis and I describe different aspects of it, but in many ways, water is a local issue. You know, if I save water here in my home in California, that doesn't help anyone in sub-Saharan Africa that doesn't have water services. Water is often a local issue, and it's too expensive to move water very far from one place around the world to another. And so we do depend on local institutions. We do depend on smart, sustainable management of water resources and energy resources locally. But there are concepts around sustainable water management that I think are global in terms of the human right to water, in terms of protecting natural ecosystems. And so we have to think about local water systems and making local water systems more sustainable themselves, more resilient to the kinds of climate changes that we know are happening. But we also have to think about how, as a global community, to provide water and water services to those communities or those institutions that are weak around the world that need to be strengthened in a consistent fashion.
Agreed. So it's very easy to see what the problem is when the nation state is failing to provide infrastructure in poor countries. But what about the wealthy countries? Like the example of Flint, Michigan springs to mind, and you mentioned it in your talk. Why do you think it is that governments, wealthy governments, fail to provide drinking water to their population?
Well, the story in Flint was a story of government failure. It was a failure to understand how a change in a water source might affect the chemistry and might affect the quality of the water delivered to the community there. It was a minority low-income community, which often gets far less attention from governments than they should because of discrimination and ethical failures. There was no excuse for what happened in Flint in a country like the United States. There's no excuse for our continued failure to provide safe water for communities in the Central Valley of California that we know have had bad water quality and lack of access to water for decades, and yet we have failed to meet those responsibilities. It's one thing when you look in sub-Saharan Africa where governments have commitments for communications and transportation and education and healthcare that they're unable to meet. It's a little easier to understand water failures in places like that, but in a place like Western Europe or the United States or Canada, those kinds of failures are inexcusable. And at the same time, there's an opportunity for the richer countries of the world to help developing regions that don't have access to the economic resources or the technology to meet their basic needs for water, to provide that assistance. The amount of money required to meet basic needs for water and sanitation for everyone on the planet is far less than the economic costs of failing to meet those needs.
Yes, that's right. So in one of the strategies that you explain in your soft path to water is that we could try and decentralize the management of water and transition to community participation. How do you envision that working?
Yeah, so a good example of that is, so in the developed world, we've built these sophisticated water systems and we collect our wastewater in big centralized wastewater treatment plants. And we treat that water often to a very high standard. And then often we throw that water away. It's dumped into the ocean. If we had decentralized water treatment systems, for example, and the technology permits us to do this now, we could collect, for example, wastewater in local communities, treat it to a very high standard, and reuse it in those local communities. It would require a more decentralized model of wastewater treatment than traditionally we've invested in. But the technology to do that exists now. And that's an option for many places in the world that have not made the big investment in centralized wastewater treatment. Let's make investments in decentralized systems where we collect locally wastewater, we treat that to a very high standard, and we can reuse that water locally. It's again, partly an answer to your earlier question about local systems and local institutions that are a little bit different than the kinds of institutions we built and relied on in the 20th century.
How interesting, because I've been wondering throughout this entire day of talks about the tension between finding solutions at nation state level versus international level versus community level. And so it seems like if the nation state is not able to provide the quality of water that is needed at country level, perhaps there's something that the communities can do to take to provide it instead.
This gets back exactly to the very last quote from Nelson Mandela, who was referring to this, that the systems we built in the 20th century, the institutions, the technology for water specifically, they brought enormous benefits to us. We have to acknowledge those. But we also have to acknowledge that they haven't brought benefits to everyone, and that there are new ways of thinking. There are new kinds of institutions. There are new kinds of technologies that can bring the benefits that we want to the communities that have not yet received them.
Yes, and I think also beyond logistics, there's also perhaps a question of political will. So when, for example, the US started to say that they would remove themselves from the Paris Agreement, I noticed that cities and states around the U.S. started signing the Paris Agreement on their on their own. So for example, I think California signed the Paris Agreement when the US started saying that they wouldn't. So perhaps that is something that we can explore further, perhaps even in the plenary tomorrow. At what level should activism and commitment to change take place? Is it individual? Is it a community level? Is it state or region level? Or is it international or nation state, or all of the above?
It's a great question, worthy of a great deal of conversation.
I'll make a note to ask it tomorrow then. Right, so we have a question for you from Simon Cole, who asks, are desalination plants sustainable? And is it fair to say that Australia is past its natural carrying capacity because population has grown so much that we need to more desalination plants at the ready? So I'm not sure if you're familiar with the Australian situation, but could you comment about desalination plants in general?
Yes, I am. So 2 points. The first is, I wrote a paper a while ago called Peak Water about the increasing limits that we are running up against as the populations, our economies have grown with a fixed hydrologic system. We're running into limits on availability and usability of freshwater resources, and Australia is a good example of that. And in my talk, I also described alternative ways of thinking about supply, and I mentioned desalination. The advantages of desalination, of course, is that 97.5% of the water on the planet is salt water. It's too salty to drink, it's too salty to grow crops. We know how to take salt out of water, and there are many thousands of desalination plants around the world that do that. And desalination has the advantage of being somewhat climate resilient. It doesn't matter if there's a drought in the whole local hydrologic system. It has the advantage of not making us take more water out of overstressed rivers and groundwater systems. But I would note that desalination plants are incredibly expensive. They're much more expensive, for example, than smarter water conservation and efficiency investments. They have an energy challenge. Desalination is very energy intensive. And if we're doing it with fossil fuels, that of course contributes in a negative sense to the climate problem. But where places are up against limits of water availability, where places have become very efficient, desalination does offer an opportunity if we're willing to do it in an environmentally sound way, if we use renewable energy, non-carbon-based energy, and if we have a good way of dealing with the very salty brines that are produced during the process. And that's a challenge that Australia has tried to deal with. Other parts of the world are starting to deal with it. So I think of it as an option. I think of it as a last resort, but it is an alternative strategy for supply.
Excellent. Well, thank you so much for your time. It was a really interesting talk, and for also taking the time to stay for the Q&A.
Thank you.
So we're now going to take a short break that will and we'll resume at 5 past. So in the UK it'll be 5 past 10 p.m. and then in the I think in Europe it'll be 5 past 11. In Australia, in Canberra, it'll be 5 past 9. And I think in the US, in California, it'll be 5 past 3. So a truly worldwide conference. So I'll speak to all of you again at that time. Thank you so much for participating. Welcome back, everyone. Now we're going to hear about hothouse Earth and how to avoid it from Will Steffen. So Will Steffen is a professor emeritus in the School of Environment and Society at the Australian National University. He is a recognized global authority on human impacts on the Earth system. And he served as executive director of the International Geosphere Biosphere program based in Sweden. He is a counselor at the Climate Institute and was advisor to the Australian government on climate change. And he's going to tell us about hothouse Earth and how to avoid it.
My name is Will Steffen, and I'm an Earth system scientist. Today I want to talk about the concept, or I should say the risk or threat, of hothouse Earth and what we can do to avoid it. Those of us who live in Eastern Australia got a glimpse of what hothouse Earth might look like a bit over a year ago. This photo was taken in the southern suburbs of Canberra, where I live, in January 2020. You can see that hothouse Earth is looming on the horizon there. In fact, at that point, quite a few suburbs in Canberra were on alert to evacuate should those flames come down. Fortunately, we got a wind shift and avoided it. But much of Eastern Australia didn't avoid the catastrophe of the mega fires of 2019 and 2020. They are just a glimpse of what might be in store if we actually do go onto a hothouse Earth trajectory. What does that look like? First of all, we need to look at what's happening to the planet as a whole. A good metric for doing that is global average surface temperature. That is the surface of the planet over the land, over the ocean, and over ice. What we can see here is that the Earth is warming exceptionally rapidly. This is the observed increase in global temperatures. These are measurements, they're not model projections. And we can see from the middle of the 20th century, and certainly from the 1960s or 70s, there's been an exceptionally rapid rise in temperature. In fact, over the past decade or two, that rate has been accelerating. We need to compare it against the background rate of the Earth itself. And to do that, we can go back to ice core data and look at what we call the Holocene reference point. It's important that we do this because the nature and rate of changes we're seeing are actually geologically significant. So the last approximately 11,700 years I've circled here is called the Holocene. It's a period of temperature and climate and environmental stability in a relative sense compared to the Ice Age and the transition that went before it. This is important for humanity because it's only during this 11,700 year period that we've been able to develop agriculture, villages, larger settlements, and the technologically advanced societies that we understand and live in today. But that now is under threat as the temperature rises past 1 degree and towards 2 degrees. I should add here as a reference point, the difference between an ice age and a warm period is actually about 4 degrees in global average temperature. It's 8 here because this is a polar ice core record from Antarctica, and there's a polar amplification fact. So already we have raised the temperature over a quarter of the way between an ice age and a warm period, but of course in the opposite direction. So when we look at the last 2,000 years of the Holocene, it looks like this. And there is natural variability, but it's in a very narrow band of about 1/10 of a degree above and below the average. And there's been an exceptionally slow cooling trend, and that's due to orbital parameters of Earth, until this last century or so, when a very rapid spike of the human-driven climate change appears on the record. So again, this is now on a much longer time frame. This is that graph I showed you of the observed temperature rise, now sitting at about 1.1 degree above pre-industrial. This is why we're getting exceptional weather. This is why ecosystems can't cope. This is why coral reefs are bleaching. This rate and magnitude is well outside anything experienced during the Holocene. If we look at the climate model projections out to the end of this century, these are from the IPCC Fifth Assessment Report, ranging from a low emission scenario to a high emission scenario, we can then map these projected temperature rises on that same 2,000 year plot. So there's the 2,000 year plot. Where we're sitting today is about here where my cursor is. And 2100, there's 1900, there's 2000. So 2100 is about here. So to give you an idea of how dramatic these temperature rises actually will be, that's what the IPCC projections look like on a 2000-year temperature record. So here's where we sit today at the end of this black line of observations at about 1.1 degrees above the pre-industrial level, which is usually measured as 1850 to 1900, somewhere back here. But when we look at where we might be going in the future, the climate targets of the Paris Agreement sit somewhere between 1.5 and 2 degrees. They're in this zone here. If we just continue on the current trajectory, by 2100, we would be 3 degrees or perhaps even a bit more above pre-industrial. The worst case trajectory, the high emission trajectory, could take us all the way up to 4 degrees or above. And that is a completely new state of the Earth system, one that we haven't seen for millions of years. And it certainly would be a challenge to contemporary civilization. I've written here possible collapse. I could easily put probable collapse for that type of scenario. But really what I want to talk about now are the risks that we might, even if we try to keep temperature in here, end up there because of the internal dynamics of the Earth system. There are things that we call tipping points in the Earth system. I'll explain them in much more detail in a few minutes. But we think the risk of starting these tipping points tipping over lies somewhere between 1.5 degrees and up to 3 degrees. We're almost sure we'll be tipping a lot of them. So the problem there is once you start tipping these elements of the Earth system, on their own, they will take you another 1.5 or 2 degrees hotter. In other words, put you in the exceptionally high danger zone. So really for us humans, the danger zone is actually lying down in here where the Paris targets lie. We did a paper in 2018 trying to analyze what this risk of tipping points might look like. And we used a thing called a stability diagram where we look at very stable states of the Earth system. This is an ice age here. This is an interglacial or the Holocene here. And the Earth over the last 500,000 to 1 million years have been oscillating between glacial and interglacial cycles. So the Holocene is up here, but we've already pushed the Earth system out of the Holocene. It's no longer there. It's accelerating away in an epoch that we are now calling the Anthropocene. So in the year 2021, we are sitting here at a very close to a fork in the road where the trajectory of the Earth system may get out of our control. So our current trajectory is toward this planetary threshold and toward what we call hothouse Earth. That's what we're on now. The tipping cascade that I'll talk about in just a moment appears on this diagram as a threshold, a cliff, a waterfall, whatever you want to use as an analogy, where once the Earth system gets sliding down towards it, there will be a point of no return where it goes across this threshold and into what we call hothouse Earth. This other trajectory, which we're running out of time to get onto, but I think we still can if we really get our act together. This embodies the Paris climate targets and the biosphere restoration. In other words, stopping the degradation of the biosphere and restoring it. This could lead to a state we call stabilized Earth, which would be hotter than the Holocene, but we could be able to park it in this little valley that we create through our activities that keep us away from hothouse Earth. But let me go now into a bit of detail about what this tipping cascade, this planetary threshold, might actually look like in reality. We know a lot now about tipping points in the Earth system. They come in 3 different types: melting of ice, which occurs obviously in the polar regions, also in the high Himalaya and the permafrost regions. Changes in circulation in the ocean. This is the North Atlantic thermohaline or Atlantic thermohaline circulation, colloquially called the Gulf Stream up in this part of the world. But of course, for us here in Australia, ENSO or El Nino Southern Oscillation, which is a coupled atmosphere-ocean circulation system, is exceptionally important. And big biome loss like the Amazon rainforest or the boreal forest. Those are types of systems that when they are pushed to a certain point, they tip into another state. In other words, they oftentimes go through abrupt change. Sometimes it's irreversible. In any case, it's a nonlinear change. We also know that these are linked and can lead to what we call tipping cascades, so that like a row of dominoes, if you start tipping the first couple dominoes, you can get the whole row to tip over. Let me explain very quickly what one of these might look like. We already know that Arctic summer sea ice is decreasing quite rapidly. We also know that the Greenland ice sheet is losing ice at an increasing rate. And what this is doing is it's pouring more fresh water onto the North Atlantic Ocean. This is starting to change the thermohaline circulation. It's slowing down. This is reducing rainfall over the Amazon forest, and it's burning more frequently. So here we have a case of where what's happening at the North Pole is affecting what's happening at the equator through this cascade, this linkage between these individual tipping elements. So we're worried that there could become a global tipping cascade that would take the Earth system as a whole into another state. The IPCC in its special report on the 1.5 Paris target already said there's a moderate risk of large-scale singular events, that's their jargon for tipping points, at a 1 degree temperature rise, and a moderate to high risk at 2.5 degrees of warming. So this period between 1 and particularly between 1.5 and 2.5 or 3 is an exceptionally important phase in climate change, one that we want to avoid, I think, if we possibly can. In terms of this global tipping cascade, a group of us did an analysis that was published in 2019 to say, where are we now in terms of these tipping points? As I mentioned, Arctic sea ice is reducing, Greenland ice sheets accelerating, Atlantic circulation is slowing down, boreal forest is burning more often, West Antarctica is losing ice, coral reefs, as we know in Australia, there's already been large-scale die-offs. They're occurring more frequently now. And interestingly, one we thought was stable, at least in the Wilkes Basin in East Antarctica, we're starting to see accelerating ice loss, which is really quite a big concern. So the point we're making here is this global tipping cascade is not something fanciful that a small group of scientists have dreamt up. This is something that we can actually see starting to move today at a 1.1 degree temperature rise. So a quote from that paper I think is very important. If damaging tipping cascades can occur, and we're pretty certain they can, and a global tipping point cannot be ruled out, then this indeed is an existential threat to civilization. No amount of economic cost-benefit analysis is going to help us. So that's the state of the science now in terms of tipping points, tipping cascades, and I think a rapidly growing risk that we could lose control of the system. Another way to look at this in terms of a climate emergency is an engineering approach, which is to say, what is the reaction time to stop the warming of the planet, but what is the intervention time to stopping these tipping points? So let me just run you through very quickly what this looks like. So let's say that the reaction time to net zero emissions is 2050, 30 years from now. Now that's a very popular target. Many countries are adopting net zero by 2050. But let me explain why this is actually a dangerous target. What are the intervention times to stop this tipping cascade from starting? Okay, Arctic sea ice, it's probably zero. In fact, we are virtually at the tipping point. Some people think we've already crossed it, and we may already be committed to having an ice-free Arctic Ocean a few decades down the track. West Antarctic, maybe 10 years before we start tipping that, and losing West Antarctica becomes irreversible. That's about another 3 meters of sea level rise embodied there. Amazon forest, maybe 15 years. Given the Bolsonaro government, if they keep deforesting at the rate they are, that could move that up to 10 years or so. So there's interaction here between direct human impact on ecosystems and what the tipping point might be based on climate change. Greenland ice sheet, we're not at a tipping point yet. 25 years is maybe optimistic. We may hit that before that. But notice that all of these are before the 30 years. All of these are before net zero by 2050. And these on their own might be enough to start a tipping cascade. So we are indeed in dangerous territory. And as we noted in that 2019 paper, are we already losing control of the system? So there are some very serious concerns that 2050 is far, far too late, and we need to ramp up action much more vigorously than that. Just a very quick note on the direct human impact on the biosphere. This is important for climate, but it's important for the stability of the planet in its own right. There was a big assessment equivalent to the IPCC on the biosphere that was published in 2019. Many important conclusions from that. I'll only give you 3. Nature is now declining globally at rates unprecedented in human history, and that's because of direct human degradation. Around 1 million animal and plant species are now threatened with extinction, many within decades. The web of life on Earth is getting smaller and increasingly frayed. And there's no controversy about this. We all understand this really well. The evidence is overwhelming. So here we have a double whammy of a rapidly destabilizing physical climate system and a rapidly degrading biosphere. What do we do about this? Well, there are some interesting ideas out there, but we're going to have to move very quickly and decisively. One of the best is Kate Raworth, who has what she calls a donut economics approach, where we need to look at this so-called environmental ceiling. These are the 9 planetary boundaries, and we're already greatly exceeding biodiversity loss. We're already greatly exceeding climate change, and many of the other ones, freshwater use, phosphorus and nitrogen, and so on. But we also need to develop a completely different type of economy that deals with equality and equity, resilience, education, food, water, health is very important. And we're far away from that in our current education system. I'll just put 3 of her main points of what an economy for the 21st century needs to look like. We need systems thinking, not linear cause effect. We have to get out of GDP thinking and think about dynamic complexity. Equity, our system should be distributive by design. Biosphere, it should be regenerative, not exploitative by design. So our current neoliberal economic system is exactly the opposite of what we actually need. I'm going to conclude now about why we are truly in an emergency. This is what the observed emission profile looks like from 1850 to 2019. So these are total emissions in billion tons or gigatons of carbon dioxide. Notice that it's been growing exponentially, 1.65% increase per year. But notice here where science has come in terms of detection of the warming signal, IPCC assessments, and so on. And here's policy, Kyoto, Paris. None of this has had any demonstrable effect yet on the emission reduction curve. The only thing that really has been the global financial crisis and COVID. And of course, they were not designed activities that were meant to reduce emissions. Here's what the pathway looks like for meeting the upper Paris target. This is the so-called well below 2 or close to 2, actually. And this is already dangerous territory. But to meet it now, we're in 2020, here's what we need to do. At least a 50% reduction by 2030. More would be better. And at a minimum, net zero by 2040. But look, if we delay only 5 years, it becomes impossible. We need to totally decarbonize in 10 years. So this is really, really an emergency situation. So our emergency is here. We have no time left before we start a deep emission reduction trajectory. This is indeed a climate emergency. The students are indeed right. So what is the COVID-19 type response? We talk about flattening the curve in terms of the transmission of COVID-19. What do we have to do to flatten the curve in terms of climate change? Well, the first thing is no new fossil fuel developments of any kind. We must stop the expansion of the fossil fuel industry. That means coal, oil, and importantly for Australia, gas. So a gas-led recovery out of COVID is completely senseless, completely crazy in terms of dealing with a climate change issue. As I said before, we need at least a 50% reduction in greenhouse gas emissions by 2030. And that means we need to achieve 100% renewable energy by 2030 or preferably before 2030. Actually, that can be done technologically and economically, but politics and vested interests are getting in the way. And as I said, reach net zero emissions by 2040 or before. These are sort of drop-dead deadlines. We have to meet these. So just to conclude, if you recall that that stability landscape diagram, that Earth floating around in the landscape, we are at that fork in the road now. It's not in 2025. It's definitely not in 2030. It's now. We have to take the right actions and the right decisions now if we want to avoid a climate tragedy. So I'm going to stop there and hopefully you'll have some good discussion. Apologies that I cannot be live in the meeting. I've got other commitments, but I hope this gives you an Earth system science background of why we are indeed in emergency status. Thank you very much.
So that was quite a depressing talk, I thought, by Will Steven. And as he mentioned at the end, he is not able to join us. So we're going to do a debate again where I will invite you to all unmute yourselves. And you don't need to wait for my invitation. Please go ahead and unmute yourselves. So the first question I want to ask is, does anybody else feel a bit of climate despair? And how does everybody deal with it? It's the idea basically that it's too late already, and that whatever we might do won't be enough to affect real change. So I think it can become quite easy to just think, well, it's too late. So how have people found interesting ways of coping with this? Is this a sentiment that others are familiar with, and are there any ideas out there on how to combat it? Yes, you don't need to raise your hand, just go ahead. Thank you, Professor Gilkson.
Yeah, well, thank you very much. I agree with basically everything which Will Stefan has said. I would only add one comment, that at this stage, the level of carbon dioxide in the atmosphere has already reached 412, but the equivalent together jointly with other greenhouse gases is close to 500. Now, at this level, amplifying feedbacks are triggered, which means once the atmosphere reaches up this level of carbon dioxide and higher temperature, a number of processes are activated on the Earth, which includes warming of the ocean, which expels some of the carbon dioxide, release of methane from the Arctic bogs, and a number of other processes which increases the emission of carbon dioxide, which means it becomes a self-perpetuating process.
Yes,
it becomes irreversible when it reaches up this level. Now, civilization and most media voices are talking about reduced emission. Of course, we need to reduce emission. We need to reduce it right down to zero if possible. But the level of carbon dioxide, of amplifying feedbacks, of gas trapping, heat trapping gases is already such that it's activating amplifying feedbacks. What can be done? Well, in theory, in principle, we need to draw down, sequester carbon dioxide from the atmosphere at the fastest rate we can. Now, this requires enormous investment, trillions of investment. These very trillions that do exist, but they are currently channeled into the military, they're channeled into further destruction. So something has to happen to wake up the powers to be, so-called, to stop preparing for the next war or nuclear war and invest in down-draw sequestration. And there are a number of methods which can do it, but whether they will decide to save the atmosphere and life on Earth or not, this is up to all of us. Thank you.
Thank you. So a good strategy to fight climate despair with action. I think that's always good because when you throw yourself into action, then there's no time. You can't afford to be pessimistic when you do that sort of action-oriented method to cope. So we have interesting comments from Gordon Weiss and from Ashley Colby. Would you like to unmute yourselves and explain what you've been saying in the chat about climate despair?
Oh, thank you. Yes, I wasn't intending to say any more. No, my experience of younger people is that there's a dangerous ennui that sets in because they're so overwhelmed by the notion of climate change, they've given up on the future. So I think we need to do everything in our power, those of us who have seen this terrible slide in the last half century, to try and stop it. Thank you.
Thank you, Gordon. And Ashley, I think you also have a good strategy to deal with climate despair.
Sure, yeah. I have moved through this psychological space of what we might call doomerism for quite a while. And it takes time, I think, for people to psychologically process what's happening. In my case, though, I moved on to become what I just recently called myself a doomer optimist, which basically means I think we have no option but to figure out these solutions. And so my day-to-day life is that researching, teaching, communicating solutions. Many of them are just being tested out. We don't know for sure, but at least doing the work of figuring it out is extremely invigorating. And I'm surrounded by other people similar to myself. So yeah, I think I'm very hopeful from that work.
Excellent. That's very encouraging as well. Maybe we should talk about one of the solutions that Steven mentioned, which is the donut. So James, if you wouldn't mind showing us the donut. Is anybody familiar with that model, and could anyone explain it further, or do you want to explain what you understood about this model and how it could help? Oh, somebody knows the donut. I think it's Tom. Tom, do you want to unmute yourself?
Yeah, yes, the donut idea has been around for a long time. Kate did a great thing by codifying it. It basically combines the planetary limits with a global social floor you can understand in terms of a broad human rights agenda. It's basically an equity-based global deal regime. It's a very high level way of thinking about the problem. It doesn't lend itself to operationalization, though, as Professor Stefan said, it implies a focus on regeneration and redistribution. And I think that it is apropos at this point in the conversation, because regeneration and redistribution in particular have to be highlighted. Otherwise, it really is impossible to imagine getting out of this predicament. So yeah, that is very relevant. What the point I wanted to make was that that we need to understand that it is not too late, and that the climate negotiations in particular are in a key moment right now, and that the Paris regime could work, but it is going to require a lot of international finance, which connects right back to the donut, because as you'll recall, redistribution is key to donut economics. It's just absolutely essential that the ambition mechanisms in the Paris Agreement be activated. This is the year when the international pledges have to be radically strengthened. If people are up to date with the climate negotiations, they know that around the world, nations, that is to say, not people, excuse me, nations are making net zero 2050 pledges, but by and large, those net zero 2050 pledges are not achievable without a terrific amount of international financial and technological support. And so it's what's the solution? Yeah, activism is the solution, but we also have to be very clear about the fact that we have to act in a manner that is primarily based on justice and spotlights the necessity for global cooperation.
Excellent. Thank you so much for your input, Tom. I think Ian, you'd like to ask a question, if I'm not mistaken.
Yeah, thank you. If I could just make a comment. You asked the question about how do we handle the concerns about it being too late. I mean, the fundamental problem is that we still do not have a clear understanding of the types of risks that Stefan has outlined in the international discussions that are going on. I mean, whether you look at governments, you look at corporations, you look at investors, and certainly in the general community, we have refused to talk about, pardon me, refused to talk about the problem honestly. And in the lead up to the COP discussions, there is no sign that that is changing. I mean, everybody is congratulating themselves at the moment within the corporate investment world on committing to net zero emissions by 2050. As Will says, it has to be achieved by 2040. In my view, it has to be achieved before that. But the fact is that what we need is to open up a conversation which honestly discusses these points, because at the moment, nobody understands it. Either they don't want to, or they've never been exposed to the information that Will has outlined. Now that has to change, and I think one of the functions of these types of meetings is that that discussion needs to be brought right out into the public arena, not in the sense of it being doom and gloom and what have you, but in the sense of just honestly saying, this is what we have to do. We can't do it with the existing systems. The UN process is not going to deliver. And we have to completely reframe the approaches we're using. Now, I mean, we know the types of solutions. I mean, the donut is certainly one of them. But what you're talking about is the type of response you have in a wartime situation. I mean, you just have to say, look, there is one issue above all else that we have to address. It is climate. And if we don't get on top of that, I know there are a lot of other major issues, but this one is absolutely fundamental. We have to address it. And the other point we have to take is we need to take precautionary steps to ensure that we don't move into that hothouse earth arena. So, the reframing of this is absolutely crucial.
Thank you so much, Ian. So we're nearly, I think we're over time actually. Paolo, do you want to quickly tell us your thoughts? You're on mute.
If I have a little time, let me, the last speaker, Jan Dunlop, talk about reframe. The question is to talk about something that nobody one talks, that is the legal status of climate. Climate in Paris Agreement since 1982 is a common concern of mankind. This means that nobody knows until today what is a concern, what are the rights and duties that arise from a concern. A concern means that we are worried about something, but we do not have recognized stable climate. The function, the Earth system function in a stable way is not a common good for international law. Without making this evolution, we will be always like this because, for example, the reason why to make less emissions is generate credits, as I think you saw that Elon Musk, for example, earned more money selling credits of CO2 than selling cars, and who are cleaning the atmosphere with forests do not earn nothing. Without changing this, we have no redistribution, we will keep the same way, and we are playing a negative-sum game. That is, to have credits, we must have emissions, and to have economic value in the forest, we need must have emissions. We have forests, and to make negative emissions, nobody pays because we are making a benefit for all mankind, and this is a legal void in international law. To clean the atmosphere today is to make a benefit in a legal void. And nobody talks about this. And without solving this problem, we have no framework to collective actions. We have no framework to clean our most important global common, that is the Earth system.
Okay, that's an interesting view of how we could use the tools at our disposal to affect change, such as legal change, regulatory change, all the things that we already have, but maybe we're not using efficiently yet. Right, so thank you so much everyone for participating in the debate. And now we're going to move on to our next talk, which I'm afraid is not going to be much more uplifting. And it is a talk about the nuclear menace by Tilman Ruff. So Professor Tilman Ruff is the founding chair of the International Campaign to Abolish Nuclear Weapons, the ICAN, which won the Nobel Prize in 2017. He is the co-president of International Physicians for the Prevention of Nuclear War, which also won the Nobel Prize in 1985. and he's the Honorary Principal Fellow in the School of Population and Global Health at the University of Melbourne. So without further ado, Professor Tilman Ruff on the nuclear menace.
My name's Tilman Ruff, and I'm pleased to be invited to speak to you today about the ongoing threat that's posed by nuclear weapons. I'm pleased to do so from Wurundjeri land, pay my respects to their leaders emerging present and past. So nuclear weapons have only been around for 3/4 of a century, but have changed things like nothing else. Even before they're used in a nuclear war, they exact a very substantial health and environmental toll. The over 2,000 nuclear weapon tests that have been conducted, including in this country, have contaminated vast areas of land for geological time, affected those most close to those tests, sometimes very severely. In some communities, whole communities in outback Australia getting acute radiation sickness, reflecting very substantial radiation exposure. And the estimated legacy of several million long-term cancer deaths will stick with us. There's also a major opportunity costs from these gargantuan instruments of destruction. Global military spending is on the rise. It's currently $1,917 billion US, almost $250 US per person alive. And it seems to go up despite recessions and pandemics. The US alone accounts for almost 40% of that, and Australia, surprisingly much greater than its population, is at number 13. In the US, the largest spender, almost half, in fact exactly half, of discretionary government spending goes on the military. The Stockholm International Peace Research Institute some years ago estimated just what proportion of military spending devoted to meeting the Sustainable Development Goals that all countries have signed on to, estimated that around 5 or 6%, which roughly equates with the nuclear weapons spend, would meet all of the health goals in the SDGs, or the water and sanitation and ecosystem and biodiversity goals, and the emergency and humanitarian goals put together. So there are extraordinary opportunity costs from doing the things we need to do. This graphic just compares the expenditure represented by the size of the circles of some key international humanitarian and health organisations compared with the gargantuan red circle represented by military spending. And recently in the COVID pandemic, people have done these sorts of comparisons of equivalent costs in health terms versus in military terms. The F-35 fighter aircraft that Australia is in the process of buying 70 of, for example, just operating those for 1 hour is sufficient to employ a nurse for a year. It's estimated that increasing global health spend by roughly as much as global military spending per person would essentially save almost 100 million lives and increase life expectancy between 3 to 8 years globally. So huge opportunity costs from that diversion of resources. But the biggest threat, of course, that these weapons posed is what happens if they're actually used in conflict. Nuclear weapons can be almost limitless in size. The largest single test explosion at 50 megatons contained about 4 times the explosive power of all of the explosives used in all wars throughout human history. But of course, nuclear weapons have unique capacities as well in terms of their ability to spread indiscriminate long-term hazardous radiation and cause global climate disruption, which I'll say more about. There are currently about 13,500 weapons, more than 90% of them owned by Russia and the United States, almost 4,000 deployed at any point in time, almost half of those on high alert, ready to be launched within a few minutes of a decision to do so. Their average size at 200 kilotons, 200,000 tons of high explosive equivalent, is about 13 times the size of the, by today's standards, relatively small tactical sized nuclear weapons used in Hiroshima and Nagasaki that between them killed about 250,000 people by the end of 1945. But there are still multi-megaton range weapons currently deployed. The World Health Organization, when it examined the effects of nuclear war on health and health services, back in the early 80s and has repeated this conclusion since, stated unequivocally that nuclear weapons constitute the greatest immediate risk to human health and welfare. They documented that no health service or combination of health services was up to the task of managing the casualties, even of a single nuclear explosion over an urban centre. And therefore, in health terms, the only logical approach was primary prevention, that is, preventing this from ever happening in the first place. The Red Cross, the world's largest humanitarian organisation, the Red Cross Red Crescent movement, similarly has repeatedly, I've quoted one example here, after a detailed study, assessed that there is no feasible or current international humanitarian capacity that could in any way respond meaningfully to the casualties of nuclear weapons use. The most important new science that we now understand relates to the impact of nuclear weapons, relates to their climate impact. People are used to thinking about climate change as related to uncontrolled global heating, but there's an equivalent opposite, if you like, climate threat that we also subject the healthy, sustainable, hospitable climate that we need for human and ecosystem flourishing. And that's the risk of an abrupt ice age conditions, essentially, from nuclear winter. Let me explain the science behind that. Nuclear weapons are extraordinarily efficient at igniting simultaneously hundreds of thousands, millions of fires over very large areas, consuming essentially everything flammable that will burn: wood, cloth, paper, plastics, petrochemicals, hydrocarbons, asphalt, vegetation, anything flammable. It's estimated that even the relatively small weapon used in Hiroshima released about 1,000 times more energy in the fires that it ignited than the explosive power of the weapon itself, and about 13 square kilometres comprehensively burnt in the Hiroshima firestorm. But a modern megaton range weapon, say a 5 megaton Chinese long range missile heading for my fair city, Melbourne, would ignite an area of around 45 kilometres across. That whole area of 1,600 square kilometres would burn at over 800 degrees Celsius, consuming most of the oxygen, and essentially nothing could survive within that confluent fire zone. Those fires would inject millions of tonnes of black smoke high into the atmosphere. The scenario that's been most often studied by atmospheric science groups is an India-Pakistan nuclear war. Been to war 4 times since independence, long contested borders, regular shooting across them, terrorist acts on both sides. This is not an implausible scenario, of course, both nuclear armed, in fact, with the 2 most rapidly growing nuclear arsenals on the planet. So this scenario uses less than 2% of the global nuclear arsenal in terms of numbers and less than 1% of its explosive yield. The acute casualties would be horrendous. Absolutely don't bear contemplation, although contemplate them we must. But it's really the climate impacts that I want to draw your attention to. So depending on the size of the weapon, from Hiroshima size to 100 kilotons, this would loft between 16 and 36 million tonnes of black carbon into the atmosphere. That smoke would spread from South Asia over pretty much all of the inhabited regions of the planet within a couple of weeks. Taking a cross-section through the atmosphere, so South Pole on the left, North Pole on the right, up in the atmosphere on the y-axis, you can see that that smoke very quickly is up in the stratosphere and mesosphere, beyond the reach of weather, traverses the atmosphere north to south, and persists for very long periods, in fact, over a decade. The right graph here shows the temperature declines for different scenarios. The 50 kiloton scenario for the conflict I've described is this black line. This purple bar is the range of minimum temperatures that occurred during the last ice age on Earth about 20,000 years ago. So you can see that middling-sized nuclear weapons, not all of those in the Pakistan and India arsenals, targeted on one part of the world, would get us down to ice age temperatures, 3 to 4 to 5 degrees colder than present. within a couple of days, essentially. That's the average. Much greater declines, about twice that or more, over the large continental interiors where most of the world's food is grown. So darker, colder, drier, underneath that cloud of smoke for over a decade is not going to be great for agriculture. There are a whole range of other impacts, unprecedented levels of ozone destruction in the stratosphere from hot smoke that would deplete ozone to levels we haven't seen for many millions of years. Radioactive contamination, toxic chemical contamination from damaged industrial facilities, and crucially, loss of all the complex transnational inputs to modern agriculture of fuel, seed, fertilizer, machinery, and transport of agricultural products. So what I'll show you is essentially estimates based on the colder, darker, drier, but be aware this is very much an underestimate of impacts because it doesn't take all these into account or the synergies between them. And essentially, both on land and in the water, net primary productivity, so that's what the first trophic layer in ecosystems, plants, basically produce, that's not used for their own growth and respiration, that's left over for animals like us to use. The total decline in net primary productivity over the globe from this small regional nuclear war would be roughly comparable to the total human consumption of food and fibre. So a very substantial decline, and of course not evenly distributed, but the most densely populated areas most vulnerable, that use more than they consume. We're not well positioned to withstand sustained substantial declines in food production of that magnitude over many growing seasons. About 700 million people are currently malnourished. About 2 billion people and growing are at least moderately food insecure at present. It's estimated that the economic and social impacts of COVID have increased that number of hungry people by roughly 100 million over the last year. Global grain reserves are currently about 3 months worth of consumption, and that's not too bad, but that's about as high as they ever get. That doesn't position us well to withstand substantial declines in production for over a decade. So it's pretty easy to see that this small localized nuclear war, small in nuclear terms, would put billions of people at risk of starvation without taking into account of the disease epidemics and likely further conflict that such a severe and extensive famine would trigger. Some of the climate scientists involved in this work have really highlighted that these are not weapons in any normal, targetable, confined sense. These are essentially global suicide bombs where the concept of winners and losers basically becomes nonsense. We would all lose if they're used. So how are we tracking? What's the danger? And then what's the way forward? Well, currently, with some current small positive steps notwithstanding, at least stopping the decline, in the renewal of the New START Treaty, the last remaining treaty constraint on nuclear weapons between the US and Russia, thankfully, in the first days of the Biden administration. But basically, there are no current negotiations underway. We have seen the hard-won treaty gains that have constrained nuclear development and numbers since the end of the first Cold War progressively abrogated. Not only that, all of the 9 nuclear-armed states are not just sitting pretty on their arsenals, they're actually modernising them with new capacities, increasing the flexibility of their use, their accuracy, and so forth. Massive sums invested, projected over very long time periods, and involving weapons types that we have not seen previously. Probably the best known and a very authoritative assessment of how we're tracking is the Doomsday Clock, this annual assessment, which just a couple of weeks ago was left at 100 seconds to midnight, as far forward as it has ever been. In setting the clock last year, the board of sponsors, which includes 13 Nobel laureates, highlighted that the international security situation is now more dangerous than it has ever been, even at the height of the Cold War. And basically this year's saying the potential to stumble into a nuclear war has grown. Some nice talk, but really no serious action yet on climate. The two main areas that concern me about this growing danger, apart from the usual ones of accidents and madness and errors in complex technical and human systems, is the growing in this pink section of this graph over the last decade or so, the rapid growth in internationalized armed conflict. I think as the impacts of a climate stressed, heating world really start to bite, food and water insecurity, people on the move, this internationalized conflicts are on the rise. Each of these that involves the nuclear armed states poses a risk of escalation. And the other area is the offensive use of cyber technology. This is now a major investment, an area of development for upwards of 30 militaries around the world. Those who've commanded nuclear weapons in the past who've been able now to speak tell us that those command and control systems are vulnerable. And just a couple of months ago, we saw an absolutely unprecedented scale and depth of hacking of multiple US government agencies, including the agency that maintains US nuclear weapons. The fissile material, the plutonium and highly enriched uranium that puts the nuclear in nuclear weapons that you need just kilograms of to construct a weapon, exists in thousands of tons in stockpiles, military and civilian, mostly nuclear armed states, totals the equivalent of reconstituting the current global nuclear arsenal more than 10 times over. So keeping this material out of weapons is going to require a very strong, consistent rules-based order that works. Getting rid of these weapons has been at the forefront of the United Nations agenda since the very first resolution of the General Assembly in January 1946 called for the elimination of atomic weapons. We can take a lot of lessons and great heart from the very significant progress that has been made in controlling the other weapons of mass destruction, biological and chemical, and the other major kinds of indiscriminate and inhumane weapons, landmines and cluster munitions. For all of them, codifying their rejection as unacceptable for all nations in a treaty that sets the same standard for all nations and provides the basis and motivation for the progressive efforts to eliminate those weapons has been the pathway for all of these. And no weapon has been controlled without first establishing that clear benchmark that these are unacceptable weapons that no nation should wield. But until very recently, that approach had not been tried with nuclear weapons. So as a result of many efforts, but of course, many supportive governments, but with a key civil society partner being the Campaign Coalition, the International Campaign to Abolish Nuclear Weapons, Australia's first Nobel Peace Laureate, and a key role played by the Red Cross and Red Crescent movement, really characterising the need for nuclear weapons elimination as urgent, unfinished humanitarian business, really helped to galvanise a process that led in 2017 to the negotiation of the first treaty prohibition of nuclear weapons. And that treaty now, as of 2 months ago, entered into force, achieving the 50 ratifications, and in fact has accrued a few since. And I'd be very hopeful, given the 120 plus nations that have supported this treaty at every step of its development, that this will continue to grow. So this is really an extraordinarily important and historic step to now have the last and worst weapons of mass destruction finally prohibited comprehensively. Not only is it an evidence-based treaty that provides this categorical prohibition, but it also is the only place in any international treaty where there is established a feasible framework, a pathway to get rid of the weapons for states with and without them, states that host them, states that assist in their possible use. There's a framework here for time-bound, verified plans subject to verification by an independent international authority to actually eliminate those weapons. There are also some landmark in the nuclear space obligations on victim assistance and environmental remediation for the victims of nuclear use and testing. One of the signs that this treaty matters is the level of consistent opposition it is and discomfort it has aroused among the nuclear armed states that are now being, for the first time, I think, really seriously challenged fundamentally about their right to continue to threaten all of us with this most acute existential threat that humans and the biosphere face. And it's interesting to see the arguments used here by the US in trying to convince its NATO allies to boycott the negotiations for the treaty. They're nothing to do with what was publicly stated at the time. They're all about recognition that this treaty would work as intended to delegitimize nuclear weapons and planning for their use. And I think there's also an element of the way that this treaty happened through the General Assembly in a way that couldn't be stopped by the largest and most powerful states was really bringing humanity and global democracy to nuclear disarmament in a way that hadn't happened before, which they don't like. This treaty has very strong support amongst the health and humanitarian sector, my area of work, and really room for everybody in civil society to engage with these issues because everybody has a bank account or a pension fund. There are vast sums of money invested in these weapons. This is the estimate in US dollars for the financial institutions' investments in nuclear weapons producing companies over just a recent 2-year period. As the writing is on the wall now with this treaty, a growing number of financial institutions are divesting from these weapons, including the world's largest sovereign wealth fund, some very large pension funds and banks and life insurance companies. Everybody can engage in this work. In Australia, banks, super funds and the insurance industry are estimated to have somewhere in the vicinity of $30 billion invested in those companies. And these tentacles go rather deep. Many of us who have university connections, our universities are involved in partnering with organisations with companies that make now illegal weapons of mass destruction, not an appropriate thing for a university to be engaged with. And I want to just reflect in closing that it's evidence-based advocacy. It was evidence of growing contamination of strontium-90 in children's teeth that helped to end atmospheric nuclear weapons tests. It was evidence about the absolutely catastrophic impacts of nuclear war and the realities of nuclear winter if nuclear war happened that convinced the leaders of the largest nuclear armed states almost to agree to eliminate their arsenals entirely back in the 80s. I've now had the privilege of being associated with 2 Nobel Peace Prizes recognising the key role of evidence-based advocacy that gains traction for IPPNW in helping to end the Cold War, for ICANN in helping to bring about the treaty to ban those weapons. So this is the existential question that we face. Will it be the end of nuclear weapons or the end of us? We all know what the answer to that question needs to be. Amidst all of the other urgent priorities and challenges that face us, I think this, in a sense, is the most acute, because getting rid of these weapons before they end us is an absolute precondition for keeping and protecting and sustaining and developing everything else that matters. So I think this is work for all of us, and the Treaty on the Prohibition of Nuclear Weapons really does provide a light that shines down a pathway that we all must take. Thank you.
Thank you very much, Professor Ruff, for this extremely interesting talk. So I have questions for you about some of the things you mentioned about public awareness. So there was a recent decision by the UK government, for example, to increase its nuclear stockpile by 40%. And as far as I can tell, that was met by no reaction from the larger public whatsoever. So what do you think is fueling this apathy from the general public?
Thanks for the question. I think it's a combination of things. Can you hear me?
I can, yes, thank you.
Yeah, good, okay. I think it's a combination of things. I mean, there are very powerful interests, you know, the largest states, massive corporations that have spent decades placating the populace that somehow these heinous so-called weapons enhance security and that this is under control, and that since the Cold War, there's been the end of the First Cold War, there was the welcome relief, misplaced, I think, that somehow these weapons had disappeared, which of course they hadn't. So there are vast industries and bureaucratic and government vested interests in keeping the populace compliant and accepting these gargantuan investments and this unacceptable risk. there are also plenty of other immediate daily life issues that confront people, especially in the current climate with COVID and all of its attendant social and economic dislocation. If you ask people around the world very consistently, the poll data in every country is generally over 70 and 80%. In many European countries, well over 90% of the population want their governments to negotiate to get rid of nuclear weapons. With few exceptions, Pakistan is really the only country where the numbers get down to sort of in the 50% wise currently. But so if you ask people, you know, everybody kind of gets this, but in terms of the daily priority, there are so many competing agendas and issues, and I think and so much incentive, you know, from powerful interests not to worry or be active on this. And of course, there's, you know, what Paul Ehlich said at the outset. You know, our neurology is poorly wired to deal with abstract long threats that seem abstract and long range. We're collectively still very bad at that. Most of the governments in the world get this too. So the first meeting of states parties to this treaty will happen probably in January of next year. And, you know, this treaty is now part of international law. But I think all of us that are concerned about human health and survival and flourishing, I think, you know, this needs to be part of our business. These weapons haven't gone away, nor can our attention to them.
I agree. So in that spirit and taking into account all the efforts that you have made to ensure that nuclear weapons are outlawed, I think one thing that oh, and I should say I did meet the ICANN people from Switzerland at a conference by the Campaign for Nuclear Disarmament in London. So I saw the Nobel Prize. It was very exciting. So I'm totally on board with the idea that this is a necessary first step. But I feel like we should point out that despite 120 countries signing the UN treaty, the nuclear powers, the ones that hold the weapons, are the ones that refuse to sign it. So what are the chances of this treaty resulting in nuclear weapons actually never being used again, when the countries possessing the nuclear arsenal are the richest and most powerful in the world? So what reason would they have to yield to less powerful and less rich countries?
Yes, I think the treaty is only obviously one tool, although I think it's a very important one. And now the ongoing work is to use this to continue the historic task of eliminating these weapons. I mean, significant progress has been made. It's the political commitment of every government to get rid of these weapons. All governments have signed on to an instrument that legally binds them to negotiate disarmament. Most of them have signed the treaties that prohibit other kinds of inhumane and indiscriminate weapons and the other weapons of mass destruction, biological and chemical weapons. You know, there's such an obvious inconsistency here that it's legally prohibited to and unacceptable to poison somebody with sarin nerve gas or subject them to smallpox or poliovirus, but it's okay to radioactively incinerate them, you know, and jeopardize their entire future with nuclear weapons. I mean, the inconsistency of that, you know, the penny has to drop at some point. So to a large extent, this has been an evidence-free zone. You know, the evidence about what nuclear weapons actually do has been really denied and obfuscated and covered up. So I think there's a crucial role for advocacy here, for divestment work, for political pressure. What gives me heart is, as I mentioned in the talk, is that the single most important thing that encourages me is that this is not some fine piece of UN verbiage that the nuclear armed states can happily ignore. This is now an international treaty, and the nature, unfortunately, the imperfect process of international law development is that it's incremental and gradual. And the force of these things grow over time as they get reinforced with civil society support, more governments join. But the writing is now clearly on the wall, and the level of consistent opposition from nuclear armed states to this treaty is, for me, the most important signal that this treaty matters. And if one looks at the record with the experience with other inhumane weapons, it's very interesting. If I just pick, for example, the United States, but it's just one. The cluster munitions and landmines treaties were opposed, their negotiation, and have not been signed by Russia, China, or the United States, the largest, most powerful states, the largest producers and users previously of these weapons. When you go to UN meetings now, for several years, the US has been boasting its virtual compliance with the landmines ban, a treaty that it opposes and hasn't signed. And they boast that they no longer manufacture landmines or cluster munitions in the United States, and that they only now deploy landmines in the demilitarized zone in Korea. So these treaties have impacts even on states that haven't joined them. The Comprehensive Test Ban Treaty has not yet entered into force, that bans nuclear test explosions in all environments. But we have a very good global monitoring system, and North Korea is a pariah state as the only nation that continues to test nuclear weapons. So these treaties can have very significant normative, political, legal weight that will grow over time, even for the nations that haven't signed them. So of course it doesn't do the job, but there are sort of two bits to this, I think, two sort of key tasks. Clearly, to prevent nuclear war in the longer term, to ensure survival of a healthy biosphere, we need to eliminate these weapons. But in the meantime, there's a lot of important and, in some cases, relatively simple steps that can be taken to diminish the danger that they'll be used in the meantime. And however nuclear, and we also know how to do this, nuclear weapons numbers have been reduced by over 80%. So entire classes of nuclear weapons have been verifiably eliminated on time by international agreement. So we know how to do this.
So I have a question for you from Professor Andrew Glickson, who asks, has it been statistically calculated what are the probabilities of an accidental exchange of nuclear missiles as time goes on? And if so, what are the probabilities?
There's different approaches to this to try and estimate the risk. I guess from a really practical perspective, lots of intelligent and people have made careful assessments, such as I reported with the doomsday clock. The world's most senior diplomat, the UN Secretary General, has said that we're in dangerous times. We're back in a new Cold War. There's no secret about this. I'm more interested from a practical point of view. This possibility is clearly real via multiple increasingly complex and diverse and unpredictable pathways. And those possibilities need to be removed, whatever the probability is. People who have managed nuclear weapons for long periods of time, such as William Perry, the 41st Secretary of Defense in the US, who's worked with nuclear weapons since the early 1960s, and many of his colleagues agree with him, is adamant that the risks are now greater than they have ever been of nuclear weapons use, even during the Cuban Missile Crisis, which he lived through, which he thought every day would be his last. So these risks are really, really serious. In a sense, they're unquantifiable, in any certain sense. But when people like Bill Perry and George Shultz and others say that the risk of nuclear weapons being used over the next few decades is at least 50%, then this is a present danger. We don't have the luxury of time here.
Well, this is a timely reminder, I think, just as the doomsday clock information has been released, that nuclear threat remains present and has to be dealt with. So thank you so much, Professor Ruff, for this really important and interesting talk.
Thank you.
You're welcome. So now let's move on to Gerardo Ceballos, who's going to talk to us about extinction and the sixth extinction and the future of humanity. So Gerardo Ceballos is a professor at the Institute of Ecology at the Universidad Nacional Autónoma de México. He is an ecologist and a conservationist known internationally for his pioneering research into extinction risk in birds, mammals, or other vertebrates and humane paths to ecological sustainability. His work underlines the extreme urgency of taking massive global actions to save humanity's crucial life support systems. And he's going to talk to us today about the sixth mass extinction and the future of humanity. Here is Professor Ceballos.
Hi, thank you very much for the kind of invitation to talk with you today. I'm going to talk about population and species losses, the sixth mass extinction, and the future of humanity. Many years ago, the great Aldo Leopold said that we live in a world of wounds. And if we look around, this is really what is happening. The place is covered by wounds that we have created on Earth by our activities. And what I do as a scientist, well, I am an ecologist from the National University of Mexico. And what I do as a scientist is basically a basic research. I love to do research, but then that research, I do it with conservation of endangered species, the establishment and management of protected areas, conservation policies and outreach. With my study group, for example, we have been able to create almost 2% of the Mexican land converted into protected areas. We work with jaguar, we work with prairie dog, we work with bison. And we do a conservation policy in the sense that we tried that our research, what we find in our research, become models and then become policies throughout the country. Some of the facts that are very important to know is the first one, probably to understand the magnitude of the extinction problem, is that only 1% of the global biodiversity, it is known. Only 1%, meaning most of the species, alive, plants, animals, and microorganisms, are unknown to science. That means that every time that we destroy a forest, we're destroying literally hundreds of thousands, even millions of species that are known to science. And an example, in the last 10 years, we have discovered more of 600 species of mammals. Since 2000, we have discovered 80 new species of monkeys. Just this year, between December and last December, 2 new species of whale were discovered in the waters of Mexico and the US, one in the Gulf and one in the Pacific. That's the magnitude, that's the wealth of the species that live on Earth. This is, for example, these are the animals found in a single trip, a collecting trip, monitoring species in the depths of the Pacific. And in this particular one, they found the largest animal on Earth, and a worm-like animal, 47 meters long. Unfortunately, as I said, what we're happening right now, we're facing an unprecedented biodiversity loss. This is probably the most urgent problem and one of the most challenging problems that humanity has faced. The current situation is that we have so many severe global environmental problems, and all of them are caused by human population growth, inequity, consumption, and the use of inefficient technologies like fossil fuels. This has caused us these global problems like climate disruption, habitat loss, overexploitation, emerging diseases, and so on, has pushed us to a larger magnitude of species and population losses on the one hand, and whole ecosystems on the other. And together, this means that we're losing ecosystem services as goods, and those ecosystem services and goods, as I'm going to explain, are essential to maintaining life on Earth in general and human life on Earth in particular. We recently published with Paul Ehrlich and other people this paper underestimating the challenges for avoiding a ghastly future. And basically what we find in this paper is that even our predictions, even what we know, doesn't give us a whole good idea of the magnitude of the problem when this all put together. Even us as scientists working on these very dreadful problems cannot grasp the magnitude of the problems. And particularly in what I am expert on is the extinction rates. And a few years ago with Paul Ehrlich and other colleagues, what we did is to try to analyze if the current extinction rates were normal in the sense were similar rates to what happened in the last few million years, or they were elevated, meaning that we are entering a mass extinction. And to be honest, when we started the study, we knew that the current rates will be elevated because so many species are becoming extinct, but we never thought that what we want to find out was as bad as we find. And basically, almost 1,000 vertebrate species has become extinct in the last 500 years, most of them in the last 100 years. Fortunately for us, there is two kinds of information that allows to put this into perspective. First, in the last 600 million years, there has been 5 mass extinction, and those mass extinction basically are extinction rates, periods where extinction rates goes and become very elevated, much more elevated to the normal extinction rates or background extinction rates. And those 5 extinction rates, mass extinction rates, have several characteristics in common. On the one hand, they were caused by a catastrophe, a natural catastrophe like the impact of a meteorite. Second, they were very fast in geological terms, happening in hundreds of thousands or a few million years. And third, they evaporated 70% or more of all the species on Earth. The second important part when we did this study is that our colleague, Tony Barnowski from Berkeley and his colleagues have put together a few years ago a paper where they have been able to evaluate what was the extinction rate of mammals in the last few million years. And that study was based on the records of literally hundreds of thousands records of fossil mammals. And what they found basically is a complex scenario, but the extinction rate, the normal extinction rate in the last 2 million years basically can be translated to this. You will expect to lose 2 species for every 10,000 species present at a time, every 100 years. In other words, in a particular century, if you have 10,000 species, in normal time, you will expect 2 extinction. If you have 20,000 species present, you will find it for extinction. And if you have only 5,000 species, you will expect 1 extinction. That becomes an incredibly important piece of knowledge that will allow us to understand what was the current extinction rate. And based on our results, we published this paper, Accelerated Modern Human-Induced Species Losses, Entering the 6th Mass Extinction, because what we found out was that the species that has become in the last 500 years in general, but mostly in the last century in particular, we can see here in this in the left, you can see the much elevated rates of mammals, all the vertebrates, birds, and so on. You see on the bottom, a dotted line, that will be the background extinction rate. That will be if the current extinction rate was similar to what happened in the last few million years, then the lines, the coral lines, will be below that. But what you can see, it is much higher. That's the first thing. I mean, the extinction rates in the last 500 years has been much more elevated than the background extinction rate of the last few million years. And the second, you can see on the right, see, that there is almost a perfect, correlation between extinction rate and human population loss. It's 0.999. That means that a human population, it is related to the loss of this species almost perfectly. In summary, from that paper, what we find out is that the species lost in the last 100 years of vertebrates, mammals, birds, reptiles, amphibians, and fishes, should be lost in 10,000 years following normal times extinction rates. And now, based on our data and the data of many other groups on plants and invertebrates, butterflies, and so on, the extinction rates are between 10 to 10,000 faster, meaning what we lost in the last 100 years should have lost in between 100 and 10,000 times faster. This means species lost in the last 100 years would have been lost between 10,000 to 100,000 years. The number is so big that it's impossible to understand. The magnitude of this is impossible to understand. But then, what we have focused our studies is not only populations, it's not only species what is matter, but it's also population extinction. Because a species become extinct when all its populations are lost. That means, by definition then, that the population extinction is more severe than a species extinction. And it will also mention why population extinction become very relevant at the local and regional scales. We published this paper in 2017, and as the previous one become also viral in the internet. It was covered in all the news and newspapers, blogs, etc. Somebody made an estimate that probably between 100 and 500 million people were exposed to this paper in the first 4 weeks after it was published. And here, what we look at, if you see the map on the right, there's the historic and the current population geographic range of lions. And as you can see, lions has become, they have disappeared for a massive, basically from all Asia, except from a tiny population in India, in the Gir forest. And also, it is all fragmented that has appeared from many places in Africa. When we did this infograph, something like 10 years ago, there were 34,000 lions remaining. Now there are around 23,000. That's how fast things are going. So we call this paper biological annihilation by the ongoing mass extinction signaled by vertebrate population losses and decline. Because what we managed to show here is that more than 27,000 species of vertebrates, 32% of them are losing population. And this includes very abundant, less abundant, rare, and very rare species, the whole array of species. So, in other words, we're losing species at really fast rate, and we're losing populations at really fast rate. And we call it annihilation of the biological annihilation because this is a really unprecedented, massive assault on wildlife, on animals. And you can see here the population had declined of the forest elephants in Africa, and every 30 minutes an African elephant is killed illegally for its ivory. As 8% of the population is lost every year, and at this rate there could be no elephants in 10 or 15 years. There are studies by other groups. This is from the Living Planet, from World Wildlife Fund, and it shows that 39% of the terrestrial vertebrates has declined around, that terrestrial vertebrates have declined around 39% between 1970 and 2010, and 76% of the freshwater species like frogs and toads, and 39% of the marine species. This is what it shows, is that the massive losses of animals, individual animals and populations. And just to give you an idea of all the biomass left of birds on Earth, 70% are basically chicken and other poultry. And only 30% of that biomass is divided among 11,000 species of wild birds. So the concentration of biomass is gigantic on poultry. The same thing is happening with when we see livestock and so on. So what are the causes of the decline globally? You know them all, but basically exploitation, hunting and overfishing, habitat degradation, habitat loss, climate change, invasive species, pollution, diseases, and so on. These are the causes directly or indirectly related to human activities that are putting species to species and populations to extinction. And I give you an example that not only big animals are being lost. This is what's happened with invertebrates. This is an example in Germany. There is 75% of the biomass of insects were lost in 27 years. Well, we know, and it will be discussed in further detail, that population growth, consumption, and technology are causing these problems. The drivers, the proximate drivers are first, habitat loss. Just to give you an idea, 90% of the tropical forests of Asia remaining in 2000 were lost in 19 years. And what we can see in this map is those places, dark places, are areas where most land is under urban landscapes, agriculture, or cattle. We know that global climate disruption is starting to hit hard. It will be much harder in the future, and it will cause more impact on population and species. The other driver that I want to emphasize here that is incredibly important is overexploitation and illegal trade. We know now that the illegal trade is so big that, for instance, animals like pangolin has lost an estimated 96% of the population in the last 20 years. A pangolin can cost $5,000 in a restaurant in China. And this is the pangolin pit where these pangolins, 3,000 pangolins, were confiscated and are being destroyed in Indonesia, I think. Wildlife trades and habitat loss are the two of the root causes responsible for the brunt of the problem of losing populations and species. And this is, we're still waiting for the big impact of climate change. And the recent COVID, we all know that the recent COVID and many other pandemic and epidemic zoonotic diseases are related to illegal trade of animals. And see the famous wet markets on the left. You will see why they call wet market, because the floor are wet with blood and water and all kind of waste. And on the left, on the right, you can see this person eating while he's eating in a place where they have cages with animals in very filthy conditions, very unethical conditions. You have there wild and domestic animals in the perfect conditions to get diseases transmitted to each other. This is why COVID jumped from a wild animal to domestic animals or to humans. And this is what has happened in the last 40 years with something like 40 to 50 epidemic, some of them very deadly diseases like Ebola. To give you an idea of the size of the problem, in China alone, over 100 million individuals of wild animals are used every single year, generating $74 billion in profit. That's more than all the combined profit from the US market, beef market profits. So why does it matter? Why does it matter? Well, it matters for so many reasons. It matters. There are political, there are religious, there are cultural, there are ethical, there are moral, there are economic reasons. Perhaps the most important, it matters because we get the environmental services that are all the benefits provided by wild plants, animals, and microorganisms to humans and to other animals and other plants. The clean water, essential for human survival, the proper combination for the gases of the atmosphere, and so on, are environmental services provided by the wild plants and animals of this planet. Indeed, there could be no life on Earth if there were no wild plants and animals. And we're killing them, so we're killing the possibilities, we're destroying the possibilities of Earth to maintain life in general and to maintain human life in particular. Another example of some of these ecosystem services is pollination. 75% of the crops that we use, human use, are pollinated totally or partially by animals. Bats, insects, bees, birds. Well, what can we do? So basically, what we can do is what we're doing today is that we have to stop being spectators. We have to become actors. And in this particular sense, it is incredibly important to understand that by losing populations, we're losing the ecosystem services at the local and the regional scale. And this is important to mention because, for instance, it doesn't matter that there are jaguars in Brazil, jaguars that disappear in Mexico, because the role that jaguars play in the forests of Mexico is gone. Those species, local species of population, are like global species. Local extinctions of populations are like global extinctions of species. This is a paper was published recently and shows particular trends. If we do nothing, how can we go to ruin? But if we do an effort in the next few years, in the next few decades, we can probably help to change the whole outcome. We think that what's happening with plants and animals in the next 15 years, what we can do to save most of the species in danger with extinction in the next 10 to 15 years is what is going to define what's happening with biodiversity on Earth in the long run. And I finish with this. We're working on a new initiative. It's called People versus Extinction, where we are building this platform to galvanize mass education, engagement, and action in response to climate change and species extinction. Thank you very much.
Thank you very much, Professor Ceballos, for this talk. So if you wouldn't mind turning your camera on, I'll ask you a few questions now. So the first question I'd like to ask you is, essentially, we're in a situation where a lot of the previous talks have highlighted the need to put an end to poverty, to increase the ability of developing countries to reach a level of wealth that will make other things possible, such as, for example, access to clean water, for example, just to name one. But with increased wealth and development, usually comes increased appetite for meat and increased consumption, increased patterns of overconsumption that could be damaging to biodiversity. Just before in the chat, Leilani Munter was mentioning the effect that all of us eating meat can have on the environment, but for you as well, with the wild animal trade, this could have catastrophic effects on wildlife. So how do you think we can reconcile the need for to lift countries out of poverty with the impact that that this will have on biodiversity?
Well, thank you. That's a good question. It is important to recognize that the way we think lifting people from poverty, it requires to increase consumption and ways that we do in the West. And actually, you can get people out of poverty while protecting their lands and protecting the wildlife, and they will be probably consuming less, but they will be out of poverty. And I give you an example. For instance, in southern Mexico, we're working with communities who were in poverty, and we are helping them to protect their tropical forests by a couple of things. On the one hand, we're helping them to develop economic activities that are compatible with conservation. And on the other hand, we're paying them ecosystem services or conservation services for protecting the forests. And it is perfectly compatible at that level, at the level of regional level, is perfectly compatible to have conservation of biodiversity and getting people out of poverty. What is incredibly complicated, and it will be extremely difficult, is if we want to get people out of poverty and keep trying to give them the same appetite for overconsumption that we do most of the affluent people of the world. That won't work. And I think the transition to, if there is a transition, as other speakers have said, in different topics towards more sustainable things, that will happen in the coming years, in the coming decades. What is incredibly important to understand that of all the problems that we have discussed here, perhaps with the exception of the nuclear holocaust, all of them can be solved with enough time. But species extinction is the only probably truly irreversible environmental problem. Once you lose a species, when it's gone, you cannot recreate it. So we have to divide this into periods. What is going to happen in the next 15, 20 years, and then what is going to happen afterwards. And what is right now incredibly important is to try to keep as much land, wild land, as possible, and to protect as many species as possible. And by looking at ways to do that without, on the one hand, destroying the species, but on the other hand, trying to get these people from poverty. What I don't know how to do it is once you increase your wealth and you just measure well-being in terms of economic growth, I don't know if that will be compatible. What I can say that there are many examples throughout the world where if we put a proper funding in the local communities, you can have working ecosystems, both in terms of maintaining the biodiversity and in terms of getting people out of poverty and having a much better standard of life. One thing that you have to recognize, and I would say this, is that by destroying, I mean, many times in many countries, like right now, the Mexican government thinks that destroying the forests and destroying the environment and get people a little bit more money, that's better standard of living, and that is perfectly incorrect. If you don't have a healthy environment, it doesn't matter if you have more money. It doesn't work that way.
I agree, and I think your diagrams showed very clearly a correlation between the reduction in the biodiversity and the increase in human population. I went to Uganda for a research trip in 2017, where they are putting in place the kind of policies and incentives that you mentioned by increasing tourism and showing the nature reserves as a source of income for local populations through tourism. But just today, there's an article on the BBC about lions that have been killed and chopped into pieces by the local population. So I suppose the more local populations get in contact, physical contact with the natural reserves, the more risk and danger there is for these local people, that they'll be attacked by wild animals. And so there is a limit, I believe, to the incentives that can be given when people fear for their life. But this friction between the natural world and the human world is occurring because a human population is growing beyond the limits of the natural reserve. So we have a question here from Tom about, did you find also a correlation between extinction rates and the size of the global economy, or did you only look for a correlation between extinction rates and overpopulation?
No, that's a very good question. Now, we have also done the correlation with the economic growth, and they are not as perfect, but they are very closely related. So, yeah, clearly this is the result of overpopulation, but also of overconsumption. And we also know that, and this is not a direct correlation, but I mean, the more land we use for agriculture and pasture, the more species were being lost. It is important to understand that if we continue having this overpopulation on the one hand, our consumption at the expenses of the wildlife, wild habitats and wildlife, there is no way we can get out of coping with global warming and all these problems. And probably you all know, and I will just repeat it here for the sake of it, but we all know that this coronavirus pandemics is related to the destruction of habitat and the illegal trade of animals. And there has been so many, I mean, the illegal trade is so gigantic now. It produces as much money as drugs and human trafficking and so on. And it is less appreciated as a problem, but that's the root of this pandemic. And Paul Ehrlich said at the beginning of this symposium that the complexity of biodiversity and producing environmental goods and services and then well-being to society is very complex on the one hand, but on the other hand, it is clearly, now there are so many studies, so much information showing that if we continue this trend of destroying the natural habitats and getting so many species extinct, there is no way we can cope with climate change and other problems in the near future. I mean, to me, the extinction, the 6 mass extinction crisis is probably right now the most pressing problem, environmental problem, because it's irreversible, it's going incredibly fast, and there is not much time to work to do something to solve it. The good news is there's still some time. If we manage to put that together, we may save many species and many ecosystems that are required to face all the environmental problems.
That was going to be actually my next question, because with your example of the pangolins and then the wet markets, it's clear that it's an international trade, and so it requires international cooperation to solve it. There's basically such a disparity between rich countries that can afford these illegal wildlife products and the poor countries where selling a pangolin is going to guarantee a fortune to the person who does it. So how do we deal with this disparity worldwide, and how do we ensure a global cooperation system to tackle the issue in a way that takes into account economic disparities?
Well, that's another good question. Well, on the one hand, I think we require now a new framework, a new international framework where we can really start to deal with this completely new dimension of the scale, the scope of the problem. We need a kind of an international Paris Agreement for climate change, something similar to illegal trade. For instance, CITES, the Convention for dealing with the trade of endangered species, is not working at all anymore. CITES, many species are becoming extinct because of legally, because you can trade them legally with permits by CITES. The disparity is gigantic and horrible. You can get people in Mexico or in Bolivia or in other places to get they get something like $70 for a jaguar bones and teeth, and they've been sold by thousands of dollars, hundreds of thousands of dollars in China and Southeast Asia. So we need, on the one hand, this new framework, and unfortunately, the world is awakening on this. And second, we need completely different a massive investment in protecting ecosystem and helping countries who still have a lot of wealth. Most of them are developing countries like Cambodia, Vietnam, Mexico, Bolivia, and so on, to maintain their forests and to increase the forest. We need this massive investment from all the countries, but especially from the wealthy countries, in terms of incentivize and help the places that still have tropical ecosystems to maintain them. And although it sounds complex, and it is very complex, it is less complex, like for instance, to tackling climate change in some senses, because you don't have to change the global economy, you don't have to change the global political system to be able to act. It is important to recognize the link, for instance, between this pandemic, the COVID, and the illegal trade. And it's important to convince and to work together, countries like the US and China and the European Union, to tackle this problem. There is no way that this can be solved with the efforts, in the amount of funds that are being put by the rich countries right now.
Okay.
Somebody has estimated that we need $400 billion a year, but $400 billion a year to tackle environmental problems is a tiny fraction of the global environmental, or the global economy. And it is time to try to organize these efforts that in the short term can be tackled, like illegal trade and protecting areas that will allow us to start to tackle all the problems in the long-term global disruption.
Thank you so much, Professor Ceballos, for this really interesting talk about biodiversity. It was extremely enlightening. Thank you. All right, and so, and now we move on to the last talk for today, which is about the risks of artificial intelligence. And this talk is by Professor Toby Walsh, who is a laureate fellow and Scientia professor of artificial intelligence at the University of New South Wales in Australia. He is an international authority on the impact of artificial intelligence and robotics on human society, and a passionate advocate for placing limits on AI and other advanced technologies to protect the public good. And he's going to talk to us about the risks of artificial intelligence.
I want to talk to you today about the risks of artificial intelligence. The risks aren't what Hollywood would have you believe. They're not some super intelligent android robot with consciousness and evil intent that's planning to take over the planet and kill humanity. That is a very long, long way away, if ever possible. We don't know if we can ever build machines as intelligent as that, and we don't know if we'll ever build machines that have anything approaching sentience, consciousness. But what we already see are risks that are appearing that are much more near term and much more to do with what might be called stupid artificial intelligence. We're handing over more mundane decisions to machines, and those are already having consequences. We see it with these self-driving trucks that you can see behind me. I want to break the risks down into a number of different categories: economic risks, political risks, societal risks, and military risks. I'll begin with the economic risks. And one of the most immediate economic risks that we see, one that surely is going to be increased by the pandemic and the recession that has provoked in many economies, is the economic risk of increasingly handing over jobs to machines. And we have seen that that's a steady trend that's happened over the last 50 or 100 years. If you go into a car factory today, it's not humans anymore that are doing the painting and welding, it's machines. Now, I normally point out that whenever a machine takes over a person's jobs, we should be celebrating that fact. That was a mundane, repetitive, dull job that we probably never should have got humans to doing. But there is a significant economic risk. What is going to happen to those people who are no longer employed in those jobs? Is there gainful employment? Is there sufficient income for those people? And we're already seeing increasing inequality both within and between countries. And I fear that that is only going to increase as AI becomes more and more capable, especially driven, we've seen historically in the past, that shocks like the current pandemic will tend to increase the need, the speed with which businesses adopt automation. And so that's a very real risk. We see this perhaps most starkly in this one graph, the only graph I'm going to present today, which is the median wages adjusted to 1970 money. And you can see that we saw productivity plotted on the same graph, median wages increase almost linearly since the beginning of the 19th century. And then there's a big disconnect that happens around the 70s as we start to adopt computing. And median wages no longer now follow productivity. We've seen continuing gains in productivity, and we'll see those continue, no doubt. But we see median wages stagnating. And that shows that whilst we run the real risk that many of us are going to be left behind as the rich or the very rich get much richer, and the worker on the street gets left behind. Besides those economic risks, there are real political risks. We see this already with a number of technologies within artificial intelligence. We see this with deep fakes. It is now possible to generate entirely realistic video and audio that you cannot tell apart from the real thing. And we are going to end up in a world, unless you saw it with your own eyes, you won't know whether it's true. And that is creating this problem of not knowing what is true anymore. And we already see politicians, we saw it with Trump, where there was compromising video caught of him saying things where he just denied it by saying it was a deep fake. And politicians are going to be able to get away with more and more by claiming that the video was faked. And I predicted that there's going to be a significant election that's going to be turned at the last moment by the release of some sort of deep fake. But other aspects, other technologies within AI are also creating these political risks that are disrupting the cohesion of our societies. We see this with, for example, with micro-targeting advertising. We see the misuse of social media that is changing the outcome of elections, changing who is president, perhaps probably changed the Brexit referendum. We have very strict rules in many countries about the uses and misuses of conventional media, television and the like, for very good reason, that we know that these are very powerful means of persuasion, and we don't want the media barons or the people with the most airtime to win elections. We want the people with the most democratic support, with the best democratic ideas. And so I think we really have to worry about, we now have a new form of media, social media, which is even more persuasive and can, at scale and at speed and at cost that we've never seen before, manipulate how people are willing to vote. There are also lots of other significant societal risks that artificial intelligence threatens us with. I think one of the greatest ones is the use or the misuse of face recognition. We are now able to recognize people in real time. This is one of these boiling frog problems, where we got used to the idea that there were plentiful CCTV cameras on every street corners. But we weren't unduly concerned about that because we knew there were too many cameras for people to be looking at. But the problem now is that we can put software behind those cameras, we can put computer vision algorithms behind those algorithms, and we can track people in real time. And we can do that at the level of the nation state. And we see this, we see the worrying trends already happening. You see this in countries like China, where such software is being used to help persecute the Uyghurs. We saw this in Hong Kong recently, when the democratic demonstrators invaded the airport. What was the first thing they did? They took down the cameras. That was the greatest threat to their ability to protest. And we also see that even in democratic countries like our own in Australia, where the government is trying to build a national database so that anyone with a passport photograph or anyone with a driving license will be in a national database, and that will be able to track people in real time. And I do wonder, I do think that perhaps we're just going to have to ban that technology, at least from public spaces. But we see this in many other settings. I'm always amazed that people are out there buying smart speakers and then ask me, and are surprised to discover that those speakers are always listening. I always say to them, the only reason that they can always answer when you say Alexa or Google is because they're always listening. George Orwell got one thing wrong. It's not the state that's going to be putting listening devices into all our homes that we're unable to turn off. People are voluntarily doing this, but paying good money to do this to themselves. And on top of those economic risks, those political risks, and those societal risks, I think there are significant military risks. And myself and many of my other colleagues working in the field of artificial intelligence have spoken quite vocally about these military risks. The risks of lethal autonomous weapons, the fact that we'll be handing over the decisions to machines as to who lives and who dies. This often goes under the name of killer robots. And that, again, that raises that spectre, that Hollywood idea of Terminator robots, but actually it's much simpler technologies. Things like drones that will be soon fully autonomous. At the moment, the drones are not fully autonomous, they're only semi-autonomous. It's large, there's still a human in the loop, this is still a human in control. But they mostly fly themselves, they just get given coordinates now, go from A to B, but there's still a human whose finger is on the trigger. But it's a small technical distance to remove that human from the trigger and have a machine make the decision as to who to target and who to kill. And we already see such weapons, such kamikaze drones, being deployed. At the beginning of this year, Turkey on its border with Syria deployed some squadrons of kamikaze drones, self-made, homegrown kamikaze drones that use face recognition software. The same face recognition software that sits in your mobile phone, that opens the mobile phone, will be used on the Turkish-Syrian border to identify, track, and potentially kill human targets on the ground. And there are immense legal, moral, and technical challenges to handing over those sorts of decisions to machines. On a legal setting, it's clear that this will violate international humanitarian law. On a moral setting, I believe it will cross a red line, handing over these decisions to machines that don't have our human empathy, cannot be held accountable like humans, cannot be punished. And there are many, many, many technical challenges that they will be terribly destabilizing, that we may end up in flash wars. Well, actually, we already know what happens when we put complex algorithms, autonomous algorithms together in settings. It's called the stock market, and we see flash crashes. When that happens, we are able to stop what happens, wind back the clock and undo all the trades, and say, I'm very sorry that there was some unfortunate feedback loop or whatever it was that caused that flash crash. But if it's autonomous weapons facing off against each other, perhaps on the DMZ between North and South Korea, we may have found that not only did we start a war, we started a nuclear war, something that we can't easily undo. So, what are the solutions? There are many complex problems here, and there is not one silver bullet, I believe, or my colleagues believe, working in the field, to be able to deal with these things. There's clearly technical fixes that we need to work on, and there's plentiful work already going on in the field of artificial intelligence to look at how do we make algorithms that are fairer, that are auditable, that can be held accountable for their decisions. But it's not just technical fixes, it's not just about coming up with better, smarter algorithms. We need regulatory fixes. There was a long period during which we believed that you couldn't and you shouldn't regulate the tech space, the cyberspace. You couldn't because somehow it was different. It was not physical. It reached across national borders. And you shouldn't, because that would stifle innovation and all the wonderful things that would come from innovation. And actually we're believing the opposite now, that you can and you should, and indeed it's necessary. And we've already seen some wonderful examples of this. We saw this, for example, immediately after the terrible tragedy that happened in Christchurch, that it was possible actually to draft regulation to call the social media companies to account for content that's posted on their website if they don't take it down quickly enough. And we see this more recently. In addition to those technical fixes, those regulatory fixes, it's clear also that we will need financial fixes to deal with issues like that, increasing inequality. The tech giants have got away with paying real tax rates way below those of traditional companies. That's no longer sustainable. It's causing significant disruption. We've seen the challenges that the media industry its advertising income has been taken away by the tech giants, and rightly, I believe, we're going to have to make sure that they do, if they're not willing to pay tax, that we tax them more heavily to ensure that they do. And I think one of the good things, at least, that's come out of the pandemic is that it's opened our eyes to the idea that we can think of more radical things, for example, universal basic income, to deal with some of the disruption that's going to happen through AI and the disruption on the workforce. Now, I don't want you to come away from my presentation thinking that AI just poses immense challenges, immense risks, because also AI can be a great force for good. Myself and many of my colleagues work on dealing with AI being applied to the 17 SDGs of the United Nations. Many of the problems I suspect that you're talking about today are ones that AI is going to be part of the solution, whether it be the climate emergency or future pandemics. There are many places where artificial intelligence, we're having machines that can make smart decisions, that can do that at speed and scale and at cost that humans can't manage, and look at data sets that humans can't possibly look at. There are many settings where AI is actually going to help us deal with some of these wicked problems, because we do face some really wicked problems like the climate emergency and like increasing inequality. And so I get up in the morning to work on AI because I see the immense positives as well as the significant risks. It is a dual-use technology, and we want to ensure that we get the good without the bad. Thank you very much.
Thank you so much, Professor Walsh. So if you don't mind turning your camera on, I'm going to ask you a couple of questions now. So the first question I'd like to ask you is, so you outlined the various facets of the problem that AI causes for the economy, politics, society, the military. Do you think it also poses an existential risk to humanity, like the other issues that we explored today?
Thank you for that question. Yeah, there is an existential risk that machines might contribute to the demise of humanity. That risk, though, is in most researchers' opinions, is a long, long way away, if ever. The idea that one day maybe we're going to build super intelligent machines, and those machines are going to have the ability to take over the planet and perhaps destroy humanity in the process. There's nothing in the laws of physics that we know of that outlaws that. Of course, there are, every science has limits, and we may run into limits that we don't know about. There are limits to how intelligent you can be. So it's not clear if we will get machines that will be smarter than us. I'm sure I think it would be terribly conceited to think that we are as smart as you could possibly be, and there's not going to be a point in some distant future where we can build smarter machines than ourselves. And we do have to worry that those machines, if we're giving them the ability to act in our world, that may have consequences for us. And so there is, though, a significant component of research within AI safety, looking at these issues, trying to ensure that when at some point in the next century or 2 centuries time or whenever it is, we build machines that are smarter than us, that the values of those machines are aligned with the values of humanity. I'm much more concerned that we need to deal with these pressing problems of the climate emergency and the possibility of future global pandemics, and also the possibilities of the ones that I talked about in my presentation, about how before we get to those machines that are super intelligent, that we're giving responsibility to stupid machines that aren't smart enough to have those responsibilities. And we're already seeing the consequences of that. We're already seeing our political processes being disrupted by people misusing machine learning to target adverts. We're already seeing the corrosive effects of social media. We're already seeing increasing inequality within society, and automation is amplifying that. So I think we're already seeing those things. And I think one of my colleagues, Rod Brooks, a famous roboticist, Australian roboticist from MIT, puts it very well. He said he's much more worried about the workers rising up before the robots do.
Excellent. We have a very interesting question from Leilani, one of the speakers of tomorrow. So I asked her to ask you her question directly, if that's okay. Leilani? Oh, sorry. I will unmute you now. Where are you? Here we go. You should be unmuted now.
Hello, can you hear me?
Yes. Oh, stop now.
Where is she? James, could you help me out? Leilani, are you able to?
Oh yeah, can you hear me?
We can hear you now.
Oh, sorry. So hi, Professor Walsh. I had a question. I read a book about artificial intelligence called Our Final Invention that was by a man named James Barat, and he discusses, how many different kinds of companies and private sectors are all working towards artificial intelligence. And is there any effort to create a regulatory body that would oversee the development of AI? And then as a follow-up question, what company do you think is the leader in the AI space? Is it Google's DeepMind, or is there another group that you think is sort of ahead of the pack?
So thank you. Interesting question. So there are discussions in various fora, international fora, about regulation, whether there be hard or soft regulation around AI. I'm actually representing Australia in the G20's Global Partnership on AI. That's a forum, one of the forums. There are other forums, the World Economic Forum, there are various forums in the United Nations looking at these things. But actually, I don't think we'll achieve anything in these fora, and I don't think they're the right place to be trying to regulate AI, for two reasons. One is that if you look at many of the issues that we have to deal with, they're about the values and the sort of society you want to be. So we take it, one of the risks I talked about, face recognition, and that's about the level of privacy, the impact that the state's going to have, and the ability for the state to surveil its population. And I suspect the answers that we come up with in a country like Australia are going to be quite different to the answers you come up with in a country like the United States, and very different to the answers you come up with in a country like China. And so to look at what we could, what consensus, international consensus we would have, would be the lowest common denominator, which would be hardly anything worth having. So I don't think actually that the international level is the appropriate level to regulate many of these things, is because the sort of levels, the sort of standards that we would get out would be barely worth having. I mean, of course, it's always worth having those things, you know, the protections on human rights and so on, are ones that we fought rightly for, and ones that we should protect. But we're going to actually have to look for stronger forms of regulation, certainly if we're going to enjoy the sorts of society that many of us think that we should have. So that's a legal answer to the question, but I think also there's a technical answer to the question, and that's by I think taking a historical lesson. We can learn from the history of other technologies. Artificial intelligence is often compared to electricity. It's an interesting comparison. I think it's quite a good comparison, because both are going to be ubiquitous technologies that are everywhere in our lives. They're going to be in our homes, in our offices, in our factories, everywhere we go. Everything is going to be powered by artificial intelligence, just like today, everything is powered by electricity. You can't imagine a life without electricity today. It provides power, it transmits the data. It is in the backbone of pretty much all of our lives, and artificial intelligence is being added on top of that. And you can imagine it's going to be as pervasive as a technology as electricity became. But if we look at the regulation of electricity, which is in some sense, from a technical perspective, a much easier problem, we didn't come up with much in the way of international regulations. We haven't agreed the voltages that we run out, the frequencies we run out, or even the type of plugs that we use across the planet. We didn't manage to coordinate on those really simple things. There were just 3 things we had to decide: what voltage, what frequency, and what shape do the plugs come in. We didn't manage that. And that hasn't stopped us productively using and all of us exploiting electricity. And I suspect the same is going to be true of artificial intelligence, which is a much more complex technology. So it's going to be much more difficult to agree universal international standards with. And so it's going to be much more likely that we're going to achieve meaningful regulation and standards if we do that at the national level. And again, because I mean, some of these things will come down to society's values about the trade-offs between the state and the individual, things like this. So I suspect that the most appropriate level, the most effective level that we're going to see regulation is not at the international level, but is going to be at the national level. And then your second question was, where do we see the most progress? I mean, it's interesting. I think this is one of the big challenges, is that we see arguably the most progress not happening in the university research sector, but in the industry sector. We see a number of tech companies who have very deep pockets, who are as wealthy as small countries, who have the scale of resources and the scale of data as well. It's being largely driven by data as well, as much as by the technology, to be able to making significant progress. And that's happening. You mentioned one of the companies. Google is, of course, ultimately an AI company, but actually, if you look at most of the large tech companies, most of the largest companies on the planet by market cap today, they are ultimately AI companies. Amazon is an AI company, Google is an AI company, Facebook is an AI company, but equally we see China making great leaps and bounds in this space, and they pose a significant challenge, an economic challenge, as well as a military challenge to the US's previous dominance. And there's certainly companies like Baidu and Tencent that have really transformed themselves in the last few years. And it's been quite remarkable as an AI researcher to see Chinese researchers go from barely being present 10 years ago in AI conferences and AI publications, in AI patents, to being, by certain measures, being the largest player. There are more, at the largest AI conference last year, we had more papers submitted by Chinese scientists than US scientists. In fact, actually, China submitted more papers than US and Europe added together. They've gone from being barely on the register to being, by many measures, the largest nation present. There are there's if you measure quality of the publications, perhaps you can still make an argument that the US is still just ahead of China. I'm not sure that you're going to be able to make that argument for much longer. And if you look at some of the recent technical advances, some of the recent breakthroughs in the last couple of years, in the last 2 years, you've seen those coming out of Chinese labs as much as out of US labs.
I'm so sorry, we're so over time. That I'm afraid I was also told before this conference that if it ever got too technical, that I should put a stop to it. So thank you so much. This is really interesting. Just one last question, but very quickly, please. So today we've had like a wide range of issues that were explored, and you made a really interesting comment during your talk. You said that when you get up in the morning, you always remember that AI is also a force for good. So could you give us an idea of how AI could contribute to the solutions for some of the problems that were explored earlier today?
Sure. I mean, if we just pick the one that's in many people's minds, the pandemic, we've seen AI being used in significant parts of actually dealing with the pandemic, whether it be from diagnosis of COVID. So the Chinese quickly developed an AI tool to actually read X-rays more quickly, more accurately than human doctors can do that, through to therapy. So AI was quickly used to actually scan through patient records to work out, well, what are the best forms of therapy, through to cure and prevention. So AI is being used to help do drug discovery and vaccine discovery, and help search through vast chemical catalogs quicker than humans could do that, and help us synthesize. These are tools. At the end of the day, these are just tools to help scientists and doctors do their jobs quicker and more effectively. So I think we can see that in many other areas, in dealing with the climate emergency and lots of other examples.
That is fascinating. Thank you so much, Professor Walsh, for your insights. And I hope you'll be able to join us tomorrow at the plenary, so that all the other experts can ask you all the ways in which AI can help, and maybe we can start a movement or something. Fantastic. Thank you so much. So this concludes our series of talks for today. Thank you to all 31 of you who have stayed until the very end. It's been really fantastic to hear such a diverse range of expert opinions on such a huge range of topics. I have to say, tomorrow is going to be even more exciting, because we're going to be exploring a bit more of the solutions. So we're going to be looking at how to clean the earth, how to usher in the age of renewable food, how to race to prevent ourselves from making our own selves extinct. And we're going to have fantastic speakers. I want to thank Leilani in particular for attending all of the talks today. She's one of the speakers for tomorrow, and we'll also have experts in the topics that I just mentioned. And at the end of the day, there will be a plenary where all the speakers who have already spoken and all the ones that will speak tomorrow will debate these issues together. So this could generate new synergies, new ideas, and I highly encourage you to attend the plenary, because you'll be able as participants to also ask questions directly to the speakers. So I hope you found today interesting, and I really look forward to seeing all of you tomorrow again. Thank you very much, everyone.